Okay, so the first thing I want to mention is that this course is very beginner friendly. The first few parts of this course will be explained very slowly and cover some very basic topics, and as we move along, we'll start covering significantly more complex topics and moving a lot faster. This is so that everyone here can actually get something out of the course. Next up, I want to talk about the video game that we'll be using. The video game is made specifically for this course, and it is special in the sense that every single level in the game requires some form of hacking in order to beat it. So you can't complete any level without hacking, and this will force you to apply the techniques that you learned within the course into the real video game. On top of this, the video game is made on a modern engine, which is the Unreal Engine. And the reason I did this is so that everyone here gets some sort of experience hacking modern games, which is slightly different than hacking older games that typically most tutorials use. So that's it. Let's move on to learning how to install all the software that we'll need. The first thing to do is to head over to cheatengine.org. Once you do, you'll be presented with this page and you have to click on Download Cheat Engine. Once you click on Download Cheat Engine, you will start a download. Here I can have it on the top right over here. Once you have completely downloaded it, I have already downloaded, so I'm going to cancel it. You'll be given this file over here. It's called cheatengine75.txt. If for you it's not 75, that is normal, is because you're downloading a newer version. I'm currently downloading version 7.5, but maybe when you're watching this course, there will be a newer version that came out. So, double click on cheatengine75.exe, and now you'll be asked to set up a language. I'll pick English, press OK. Next up, it will bring up the installer. Next, click Decline to the RAV Endpoint Protection Elite. Over here, Decline. Then on the McAfee Web Advisor, please click Decline. Once it is done installing, you can simply click Finish, and this will launch the application. If this shows up, just press Cancel, and now you have Cheat Engine opened. Now to open Cheat Engine again, you can simply double click on the icon that showed up on your desktop. And that's it. That's how you install Cheat Engine. Now let's move on to how to install the video game. Now head over to the course content, and under the lecture you're currently watching, the Installing the Game lecture, there will be a resource button. Just click on it and you'll have a game.zip. Click on it and this will download the game. Okay, so what you can do now that you have downloaded the game file, right click on New, click Folder, and here you can name it Game Hacking Course. Once you do, simply open this one, and then this may take a bit of time, but simply select all of them and drag and drop them over here. This may take a bit of time. I'll come back when it's done. Now, once it's done, you can simply open it and double click on the beginner course.exe. Once you do, you may get this window pop up, which is going to say that your Windows Defender is protecting you in case there is a risk, but don't worry, there is no risk. Just click on More Info and click on Run Anyway. Okay, so once you do, you'll be given this window, and here you'll have the 6 levels of the game. The first thing I recommend is that just in case that it appeared in full screen for you, just press F11 in order to have it windowed. It's going to be much easier to switch between Cheat Engine and the game as we try to hack it. So press F11 to go into windowed mode. Once you've pressed F11, I recommend that you go into all the levels and try to complete them. You can click on level 1 and the instructions appear here on the left. If you want to hide the instructions, on the top left it also mentions that Enter hides the instructions and Enter shows them again. Escape returns to the main menu. This works for all games, so all levels, so you can press Enter to hide the instructions and Escape to return to the main menu. And then I also want to point out that the controls are very basic. All you have to do is move around, is WASD, like most first-person shooters, space to jump, and to shoot, you just press left mouse button. So just click, and then that's it. So that's how you play the game. Okay, great. We can finally get started. The first thing we're going to do, though, is cover a little bit of theory, and I promise I'll keep this as short as possible. What I want you guys to understand in this video is what video games really are. Video games are really just numbers, a bunch of numbers, and that's it. That's all they are, just numbers. And what I mean by this is that there is a number, for example, for your health, or a number for the ammo of your weapons, or a number for the position of your player. And in fact, in video games, there is probably millions, if not billions, of numbers. And all these numbers are stored within something called the RAM or memory of your computer. What RAM really is just a bunch of tiny boxes, and each box can hold a number. So, for example, your health will be given a box, and the box can hold the number 100, for example, if you have full health. And in this case, for example, the ammo points to a box that holds the number 7, meaning that you have 7 rounds left in your weapon. Awesome! We can now look at our first example. If you look at the bottom right of the screen, you can see that we have 7 out of 7 rounds. However, as hackers, we would like to have 500 rounds instead of 7. To achieve this, we'll have to find a box within the RAM that holds the value of the ammo, and change that value to 500. Now, let's have a look inside the RAM. Inside the RAM, you can see that there's 2 boxes that hold the number 7. We can completely disregard the other boxes because we know that we have 7 rounds and therefore the box must hold the number 7. However, we're still left with 2 boxes and we don't know which one of these 2 boxes is the correct one. To find out which one is correct, we'll have to do a bit of investigative work. What we're gonna do is shoot around within the game, which will change the value of the ammo. Once we do so, we'll go back into the RAM and we'll see that one of these 2 boxes has now changed to 6. The other box still holds the number 7. This means that the box at the top is the correct box. This is because it reflected the changes that we made to the ammo. The other box can be completely ignored. This box, just by pure coincidence, held the number 7 at the beginning. This will happen very often when we're looking for values within the RAM. There are so many boxes and so many values that there will be many boxes with the same values. What we'll do is filter over and over again by changing the value repeatedly up until the moment that we're left with only one result. Okay, great, we're almost done. Now that we have the box, let's simply change the value inside to 500 and see what happens within the game. Great, now you look at the bottom right and we have 500 rounds instead of 7. Awesome, so now you know how the most basic version of hacking works, which is to simply find boxes within the RAM and change the values. In the next video, we'll actually do this within Cheat Engine. Alright, see you soon. Great, so now let's look at how Cheat Engine works and let's get over the first level in the video game. So let's open Cheat Engine and then open the game. And then once we have both open, we'll go to the top left here of Cheat Engine where there's like this red and green highlight. And this will bring up the process list. So every program that is open within your computer. And within this list, we can find the video game. So here, beginner course, double click on it or press open. And all this does is tell Cheat Engine which process we want to attack. So which part of RAM we're actually interested in. If we don't do this, Cheat Engine can't search for any values. And it's very common to forget this step. A lot of people forget it. So I'm going to keep emphasizing it. Press on this button, select the game. This is always the first step before you actually start using Cheat Engine. Okay, great. So now that we've done this, we can head over to level 1. And on the left here in purple, you can read the instructions which say to complete this challenge, you must obtain 500 points. To get points, you can shoot the blue boxes. Each blue box gives you 5 points. However, you do not have enough boxes to reach 500 points. The number of points is stated at the top of your screen. Okay, so here at the top of the screen, we have 0 points. We're in this video game. And okay, let's shoot some boxes. What happens? So as we shoot boxes, we get 5 points for each box. And so now we currently have 10 points. Now, we want to change these points to the number 500. And in order to do this, again, we have to find this box that holds the score. And the score we know currently has the number 10. So we're going to look for every box that currently has the number 10. So head over to Cheat Engine. And here where it's written value, you can put in the number that you're going to look for. So here, press 10 and click first scan. Once you do this, Cheat Engine will give you all the boxes that currently hold the number 10. So there's 34,000 of them, so there's a lot. All the red ones, we'll look at this later, are ones that have changed since the last scan. And as you can see, a lot of these values just randomly change and just happen to have the number 10 when we first scanned. Regardless, there's 34,000 boxes, and so this is not good enough for us. We have to find the one in all of these that actually holds the score. So to do this, let's go back into the game, shoot a new box, and see how many have now the number 15. As you can see, a bunch of them still have the number 10. And so we have to look for the one that has the number 15. So let's search for that. Now, be careful here. Don't press new scan. If you press new scan, it restarts from the beginning. What you want to press is the next scan. So press next scan. And now we have 6 boxes left. This is good news. We're really close, but 6 is still not good enough for us. As you can see, a bunch of them still change a bunch. So anyways, let's shoot another one. We'll have 20. You can search for the number 20. Click next scan, and this gives you the 2 boxes that currently hold the number 20. Now, this will happen very often where you're going to have 2 boxes that seem correct, or many actually that seem correct. And as you can see, if you shoot more boxes, they both update to 30. And so they both seem correct. They both update to the right number. And however, only one of these is the actually correct one. So let's double click on each one of these, which will bring them down here. So if you double click and double click, you'll have them both here. And once you have them here, you can actually change their value. So I'll go with the last one first. And when I change this, let's say to 100. So go to value, hold your mouse over the number and double click the number. This will bring up this menu. And now you can change the value. So now let's say 100 and press OK. Once you do this, you'll see that for a second, it's updated to 100. It went back to 30 and the score did not update. Great. So we know this is the wrong box. You can right click and press delete this record, or you can press the delete key as well. This works too. So now let's go over it again. Double click on the number of this box. Now let's change this one to 100. Press OK, and wow, there you go. Finally, this one works. So we found the right box. I'll go over why we had 2 boxes that seemed correct a little later on, but for now, just know that if 2 boxes seem correct, or many boxes seem correct like this, that they all update correctly, what you can do is just try changing the value and see which one sticks, like the new value that you set actually updates within the game. Great, so now we have the right box, and now we can simply write 500, press OK, this reaches 500, we get a congratulations message, and this gives us the menu again. Yep, all right, perfect. Great. So we found the box. Now, so this is essentially the first hack. So you find the box, and now you can update the value. So now I'll just cover a few little cheat engine tricks that you can use to make your life easier. So under description here, you can double click on the no description, and this will bring up this menu. And then you can change the name, let's say to level 1 points. Great. So now you have level 1 points. And now, so if you head back to level 1, you can see that now it holds the number 20, which is the correct number. And you can change it again to 500. And there you go. Now this is going to go back to the main menu and you win again. So by doing this, the description, it'll give a real name to the box that you can keep up for later on, which is really useful. So that you don't get lost when you have a bunch of entries here. Also, I want to cover that you can actually save these results. So press on the little save icon here. And this will bring up your file explorer. You can choose where you want to save it. Press save. Now that you've saved it, you can actually close Cheat Engine and open Cheat Engine again. Again, press on this button here. Open the beginner course. Click open. And this will pop this up, which says load the associated table. Say yes. And this brings up back the value. Now you head over back to level 1. And as you can see, you already have the box. So you can press 500 and you don't actually have to search for it anymore. Okay, so great. So now I would like you guys to try to do this on your own on level 4. So go on level 4, and this is the same level that we used for the previous video. Press enter to hide the instructions. And now you have 7 rounds and you have to shoot all the boxes. But then you run out of ammo and you can't destroy them all. So I'd like you guys to give it a try and try to use this technique to find the box for the ammo and give yourself enough ammo in order to destroy all the boxes. Okay, perfect. I'll pause now and I'll come back with the solution in a bit. Okay, so let's see how I would do it. So I would head over to level 4. I now have 7 rounds left, so I can hide the instructions. So I have 7 rounds, and I know the box holds the number 7. So let me search for all the boxes that hold the number 7, which will give us a lot of boxes, 55,000. Okay, I'm gonna shoot one. Now there's 6, so let's see how many boxes hold the number 6. 63, not bad. Let me shoot again. Now I have 5 left. Let me see again. Okay, 12, getting there. Shoot again. Now 4. Let's see how many have the number 4. Oh, there's not that many, so we have 5. Let me shoot again. Now we have, let's see how many. Oops, we have 3 rounds. So next scan. Okay, we have 3 values, and I'm gonna assume that these 3 as these 4 are again like, yep. Okay, so they all seem to be correct. So let's figure out which one of these is correct. So double click, double click, double click, double click. Great, we have them all. Now let me try changing the value. So let me start with the last one again. Oops. So 100. Nope, didn't work. This one 100. Ah, this one worked. Okay, so we found the right one. I'm gonna delete the other 3 boxes. Great. And now let me give myself 1,000 rounds. So hey, 1,000. Great. Okay, cool. So this is how I would do it. Then you can go around destroying all of them. Now I want to show you guys another neat trick, is that instead of just giving yourself a large amount, you can actually freeze the value. So let me give myself 1 round. So now I have 1 round technically. However, if you go here and you click on active, so the little checkbox here, this red box here, will freeze the value. So it will cheat engine, every time that the value changes, it will go into the RAM and set it back to its previous value. So it's gonna try remaining at 1. So no matter how much you shoot, you can see that it technically drops. Sometimes you can see a 0, but it always sets back to 1. So this is a way to get infinite ammo. And there you go. Now we come back to the main menu. And now I want to point out another thing that is special about level 4. So level 1 was great because you head back to level 1 and you can go into the box that you found, write the number 500 and win immediately. However, if you go into level 4 and you try going into the box that you found and changing the value to whatever big number that you wanted, now the problem is it doesn't work. So as you can see, we still have only 4 rounds, not 1,000, and it's not working. Essentially what's going on is that level 4 changes where the ammo is stored within RAM, so it changes to a new box at every time that we reset the level. This is not too important for now. I just want to point out that you can't save this result and expect it to work over and over again. We'll see later why this is the case, and you really don't have to worry too much about this because in a couple lessons we'll see how to automatically find the box every time that we restart the game. And so there you go. All right, I'll see you soon in the next video. Okay, so let's open Cheat Engine and the game again. And attach the process, never forget. Click beginner course, click open, load the associated table, say yes, great. So never forget to do this. Again, this is very common to forget. So just remember this button, select the course, the game, beginner course, and click open. Great. Now that we've done this, head over to level 2, and lucky for us, for this topic, we won't need any additional theory. So let's open level 2 and read the instructions. It says, this challenge is very similar to level 1. The main difference is that you only have a progress bar for the number of points. To complete this challenge, you must obtain 1,000 points, and to get points, you can shoot the blue boxes. Each blue box gives you an unknown amount of points. So there's 3 differences here. The first one is that we get an unknown amount of points for each box. The second one is that we need to reach 1,000 points instead of 500. And the last one, and most important, is that we don't actually have a display for the number of points. So if we shoot the boxes, we see that we increase the number of points, but we don't actually have the number of points. If we head back to level 1, we can see that we have an actual display for the number of points. So let's go to level 2 and see how we can actually solve this. So we don't know how many points we have. So if we shoot some boxes and we go here to put how many points we're looking for, we'll see that we can basically not write anything because we don't know how many points we have. This will happen very often. A common example is sometimes games have health bars that don't have a number. They just have a red bar that shrinks when you take damage. There's a bunch of other cases like this. The more you hack video games, the more commonly you'll encounter these issues. But lucky for us, Cheat Engine has provided us with something called scan types. So here you can see that you have scan types, and currently it's set to exact value. So up until now, we've been using exact value because we provide the exact value that we care about, and this gives us all the boxes that have that exact value. But if you click on it, you'll see that we'll have 4 additional options. Bigger than is essentially giving us, as the name suggests, every box that has a bigger value than the one that we provide. Smaller than does the same, but the other way around. However, notice that bigger than doesn't include equal, so it's not bigger than or equal to. So if you press bigger than and you write, let's say 30, it will give you all the boxes that have 31 or more, not 30, okay? Be careful with this, it's very common to make that mistake. Next up, we have value between, which is a value between these two, which is essentially a mix between bigger than and smaller than at the same time. And then we have unknown initial value. Unknown initial value is a very weird one, and we'll see when we actually need to use this. But it's essentially for when you have absolutely no idea where to start your search. And ideally, you never use it, because if you try doing this and you press first scan, you'll see that it will give you 625 million boxes. And this is a very large number, and it's very slow to scan through all of them, and so we'll avoid using it as much as possible. Now, to reset everything, click new scan. This will bring us back to the beginning, and we can try using something different. So let's use bigger than, and let's say 0, because we shot a few boxes already, so we know that we have more than 0 points. So let's do bigger than and do first scan. Now we get 40 million results, which is already better than 600 million, but it's still pretty terrible. So let's now use smaller than. So you can find it here, smaller than. And we know that we have less than 1,000 points, otherwise we would have won already. So let's do 1,000 and do next scan. Okay, so we went from 600 million to 40 million to now nearly 9 million, which is great progress already. Now, if you press now, you'll notice that you have significantly more options. These options appear once you've already scanned once. And the reason is because it includes stuff like increase value, which compares to the previous value from before and gives you all the boxes that have increased since the last scan. We can actually use this right now. So let's do increase value, and then let's shoot a box. We know that the points increased, and so all these boxes, for example, have not increased at all. So we know that it's none of these, so let's do next scan. And this will give us 1 million boxes. We can keep using this, so let's keep shooting a couple and do next scan again. And as you can see, we're doing great progress. Now, the other options include increase value by, which we need to provide a value for. However, as the instructions say, we don't know how many points each box gives us, so we don't know by how much we've increased the points. Next up, we have decreased and decreased value by, which is the same as the increased value options. And then we have changed value, which is the same as increased value or decreased value. And unchanged value we'll use in just a second. So press unchanged value. Unchanged value will get rid of essentially all of these boxes that randomly get updated constantly. These boxes are very annoying, and they clearly not the boxes that we care about, so we can use next scan with unchanged value. And since we haven't shot any boxes, we know the score remained the same, so we can use unchanged value and press next scan. Now, as you can see, there's still some of them that remain, and we can basically spam this option. So press next scan, next scan, next scan. And as you will notice here to the right, there's the option to repeat this option. Now, this repeat is there because this spamming of the next scan with unchanged value is very common, so Cheat Engine just allows us to do this very easily. So press repeat and press next scan. And this will continuously scan over and over again and remove all the ones that have been changed. Now, to stop this, press the repeat again. A little warning about unchanged value. Although it's very tempting to just use it immediately and press repeat and next scan, the problem is that if you have a lot of values, let's say 9 million or more, or in fact anything above, let's say 10,000, it's quite a bad idea to use the unchanged value option, because there is so many values to scan through that every repetition will take forever to execute, and this will slow down your computer by a lot. So be careful when using repeat. Now, to use this repeat unchanged value, we can also use a little bit of movement within the game. So let's move around, and you'll see that this drops even more the count. So if we start shooting, this also increases the value. And the reason for this is that everything within the game has, as I said, a number attached to it. Even the position of the player, where the gun is pointed at, if you shoot or not. So all of this has numbers attached to them. So every time that you make any change that is unrelated to the points, this will change a bunch of boxes within the game. And this will allow us to use this unchanged value more efficiently. So just move around the game, make changes within the game that don't affect the value that you care about. Now press repeat to stop this. And now we have 453 remaining, which is way better than the 40 million, or I don't remember exactly how many millions of boxes we started with. Now let's go back to increase value and shoot a couple boxes, press next scan, and now we have 35. We're getting there. A few more, next scan, 16, a few more. Let's see if this helps, 11. Okay, now what we can do is be a little bit clever and shoot all of them. And as you can see here, we've passed the halfway points. And we know that if we pass the halfway points, that means that we have more than 500 points. So let's do bigger than 500 and do next scan. And this leaves us with 3 total. It might leave you with only 2 or more than 2, depending on how many results you had before and a bit of luck. Now, clearly, we have less than 44,000 points. This is because if we had more than 1,000, we would have already won. So we know we can discard this option. So let's remove this address. And now we have left with 2 options. Now, this is, again, one of those cases where we have 2 values that seem correct, and we have to determine which one is the real one. So let's double-click on both and bring them down here. And let's change the value. So let's do here 100. And this did not work. Let's try the other one, 100. This one worked, so we know this is the right value. Let's delete this one. And now let's do 1000 and see if we win. We won. Great. Okay, so as you can see, this kind of search is a little bit more tedious. It's a bit annoying to do, but with a bit of creativity and using the scan types in a clever way, we can actually get to the result no matter how weird or difficult it is to find these type of values. So just be patient, be creative, and be careful with which scan type you use. And that's it. So now let's rename this to level 2 points. And we're basically done for level 2. That's all we had to do. So let's go back to level 2 and notice that, in fact, this one also works. So that's good. We can just reset the level and keep using the same box. We don't have to look for it again. That's really good news. And now I just want to point out a couple of tricks that we haven't used in this case, but that could be useful for you in different situations. So when you choose, let's say, bigger than, you will be given a not option. This not option will negate this and do the opposite of the scan type that you want. So for example, bigger than, not would mean less than or equal to. And so smaller than would be very similar. So not would be greater than or equal to. Anyways, that's all I wanted to point out. Now, don't forget to press save. Select where you want to save, press save. If you want to replace it, say yes. And there you go. Now we've replaced it and we've saved our results. And that's it. That completes level 2. Now, in the next video, we'll cover a completely new topic. So stay tuned for that. And I'll see you soon. In this video, we'll be covering some theory again. And again, I promise I'll try to keep this as short as possible and only give you the necessary information. So you've probably heard the term binary before. Binary is the way that computers see numbers. It's just zeros and ones, so off or on. In the example in front of you, you can see the way that computers see the number 75. Okay, now let's go back to RAM. RAM is really just a place where we can store zeros and ones, and so video games or any other process can use it to store numbers. Now, you probably also heard the term bit, which is the way that we refer to a single digit of binary, so a 0 or a 1. And then we also have the term byte. Byte is the way that we refer to 8 bits all put together. Okay, so now let's go back to those boxes from before. I want to clarify that those boxes don't actually exist, at least not physically. As we've said before, the RAM really is just a bunch of zeros and ones, and there's no real boxes there. However, game developers need to split up those zeros and ones in order to store different values in different places. Essentially, game developers are just deciding which bits belong to which values. So they say this group of bits can hold the health, for example, or this group of bits can hold the ammo, and so on. And they do this for basically all the values of the video game. What I want you guys to take away from this is that those boxes are very theoretical and they don't physically exist. So essentially, they can be made up of any size and placed anywhere. In this example, we've made up a box of the size of a byte, followed by a box of the size of a bit, and then again, a box of the size of a byte. Now, for your information, and this will be necessary for later, one of the most common sizes of boxes is 32 bits or 4 bytes, which is the same. 4 bytes times 8 bits is 32. Finally, the last comment I'll make about these boxes is that pretty much every single video game, and what I mean by pretty much is literally every video game that I can think of and every program that exists on a computer, will have boxes of the size of a byte, 2 bytes, 4 bytes, or 8 bytes, and essentially nothing else. There's a little bit of an exception with bits. Sometimes a single bit could be considered a box, but even there, it's very rare. Okay, so until now, we've only really used integers. So numbers that are a whole. So like 0, 100, 42, 100,000, minus 352, anything that is a whole number. However, it's very useful for video games or pretty much any program to be able to write something called floats. And floats is the computer science way of referring to decimal numbers. So numbers that have a dot followed by more numbers. So numbers like 0.145, minus 42.3, and so on. Okay, so now you may be wondering, what does a floating point number actually look like within RAM? The answer to that is, unsurprisingly, again, just zeros and ones. It looks exactly the same, at least to our human eyes. However, the number that is represented by the zeros and ones, if it's an integer, is completely different to the number that is represented if the box holds a float. As you can see on screen currently, we have a 32-bit number, which is 4 bytes again, and it holds a completely different integer than a float. However, it looks exactly the same. This is called the type of the box. So there's the integer type or the float point type, and there's many other types that we'll explore very soon when we go back to Cheat Engine. For this reason, we must tell Cheat Engine what kind of box to look for. If we're looking for the value 200 as a float, but we make the mistake to tell Cheat Engine that we're looking for the value 200 as an integer, it would look through all the boxes as if they were integers and completely miss the 200 because it will read off the 200 as some completely different value because it was reading it as an integer and not as a float. So again, it's the exact same box with just zeros and ones. However, we have to specify how to read the zeros and ones within this box, whether it's a complete whole number like an integer or a number like a float. So that's it. It's essentially two different interpretations of the same zeros and ones. And we have to be very careful when telling Cheat Engine which type of box to look for. Just in case some of you are interested in how the floating point notation really works and how they're interpreted by computers, you can look up the IEEE floating point standard notation, which basically will explain to you that floating point numbers are stored in scientific notation, which is a very interesting topic, but a bit outside of the scope of this course. However, feel free to look it up, it's very interesting. Okay, so now last little thing I want to mention is that, and I'll make this really quick, is just a little detail. So floats are typically stored within a 4-byte box, and so if you're looking for a floating point within a 4-byte box, you say that you're looking for a float. It's very obvious. However, sometimes you'll hear the term double, and we'll do so as soon as we go to Cheat Engine again. And double, all it is a double precision floating point number, which is just a float point number that holds within an 8-byte box instead of 4. So essentially, float is the standard 4-byte box, and a double is an 8-byte box. Okay, that's it. See you soon. Okay, great. So now that we've covered all the theory about floating point numbers and data types, we can actually put it to use. And for that, we'll head over to level 3. But before, remember, attach to the process. Use this button, use beginner course, and then get started. Level 3. Okay, instructions. For this challenge, you must get across the purple wall. So we want to get across here, so to the other side. And the wall can be raised and lowered by shooting the buttons on the right. So over here, up and down. Now it says, notice that you cannot simply lower it enough to pass over the wall. So we can't just shoot the button here in order to jump over it. And it also says the height of the wall is stored as a double precision floating point number. That's really important, the fact that it's a double. And then it also says the floor is at a height of 0 and the maximum height is 400. So let's head over to Cheat Engine and see here that it's written value type. Currently, it's set to 4 bytes. And there's way more options. One of them, for example, is byte, 2 byte, 4 byte, and 8 bytes. All 4 of these are all entirely reserved for integers. So it's just different sizes for a box that holds an integer. Then we have float and double. This is what we're interested in. Float is the 32-bit version, and double is the floating point number of 64 bits instead of 32. And here it says in the instructions that we need a double precision floating point number. So we're going to be using the double option. Now, there's also binary, string, array of byte, all, and grouped. All of these options we can be completely ignored for now. We won't use them as we haven't learned anything about them. So for now, click double. And don't forget, if you don't select double, you won't be able to search for the value, as again, Cheat Engine will interpret all the boxes as integers if you keep it at 4 bytes. We want to consider them to be doubles. So open the double one. Select the double. And now let's actually get started on the search. But for this, we're going to be a bit clever. We're going to take a shortcut. And we know here that the maximum height is 400. So what we can do is raise completely all the way up. Once we know it's all the way up at 400, we can search for 400 and press first scan. Remember, we're using scan type of exact value. This gives us 500 different results. So now we can lower it. And then we can use decrease value and press next scan. 47, not bad. Let's go up again. So increase value. Next scan, and now lower it again, and then decrease value, next step, next scan, and now we have 31. We can then do a bit of unchanged value with repeat since we don't have that many. So press next scan, run around, shoot a little bit. Once you shoot, you'll have 25. Okay, now stop it. And now we have 25 of them. However, as you can see, they all look correct. So if we go up, it goes up. If we go down, they all kind of go down. Except maybe this one, but whatever. They pretty much all look correct. And in order to deal with this, we're going to use a little bit of a trick. So press on the first one, go all the way down, hold shift and click. This selects all of them. Press on the red arrow here, which will bring them all down here. Now we have all them down here. Now the trick goes like this. What we're going to do is try changing half of them all at once. See if that causes a change, and if it does, we can discard all the other ones, and if it doesn't, we can discard all the ones that we've selected. So for example, let's select the first one, let's select roughly around the middle with shift. So again, select the last one, hold shift, click on roughly the middle, right click, and then say change record. Now, go to value, and here we can change the value of all of these all at once. Okay, so again, just so you don't get lost, the last one, you click on it. Then you go roughly around the middle, hold shift, click. Once you've done this, click right click. So right click here around any of these that are selected, then click change record, then value, then what value to change this to, and then let's say 300, why not? Press OK, and this erases the wall, right? Now, since we change all of these, that means that one of these is the correct one, and everything else is not. So we can delete all of these. Right click and then do delete record. Now, we can go to the first one, go roughly around the middle, and repeat the same process. So right click, change record, value, and then let's change this to, let's say 100, and press OK. Now, it didn't do anything. That means that none of these are the correct one. So we can right click and delete all of them at once. Okay, now let's do the bottom three. So select all three, right click, change record, value, and let's do 100. Press OK. This drops it all the way down. So it's one of these three and none of these three. So we can select all the top three, delete all of them, and now we are left with only 3 values. One of these is the correct one. We can change them one by one now that we only have 3. So let's do 200. Nope, this one didn't work. 200. Nope, this one didn't work. And then 200. And oh, this one worked. Okay, great. Now, if by some mistake this doesn't work and you accidentally delete the correct one, you still have all of these still in the search area. So you can again click on all of them and then bring them all down in order to find it. But anyways, now delete the 2 that we don't need because they're wrong, and now we know that this one is correct. So we can, let's say, put it at a height of 1, which is basically on the floor. We can rename this to level 3 wall height. Press OK. Okay, now that we've done this, we can go all the way to the other side, and we get the congratulation message. We won, and there you go, we found it. Now, again, we can just go back, go in, set this to, let's say, 400. Okay, it goes all the way up. We can set this to, let's say, 800, which will bring it all the way up there. And now we can go under it, and then we also win. Great. Now, again, notice that this result remains correct no matter how many times we restart the level, so that's good. And also notice that here the type has changed. So now we have 4 bytes, double. Okay, so here we know what active does. It freezes the value. We know that the description is just for us to read it. We know that the value is what's inside the box, and we know that type is the size and the type of the data inside of the box. So now we're left with this address column here that we don't exactly know what it does just yet. That's what we'll be covering in the next video. So stay tuned for that. All right, see you soon. Okay, so in this video, what we're gonna try to do is understand the difference between level 4 and level 1, 2, 3. And what I mean by difference is that if you recall, in level 1, we can simply refer back to the result that we searched before, give ourselves as many points as we want, win the game. Level 2, same thing, right? And level 3, we can do the same. We can drop the wall down, great, and we can walk over and win again. But in level 4, we can't refer back to our results, right? So if I search for it now, okay, so now that I found it, and as you can see here, we can give ourselves 10,000 rounds if we want. And now we hack this game, we can destroy all the boxes and get over it. But now the problem is that as soon as I leave and I come back, all the results are gone, right? So although here I have 9,000 rounds, in the game I really have 7, and then I have to look for it again, which is very inconvenient. And so we're gonna see how to fix this and understand why it's happening. So there you go. All right. Okay, so now let's try understanding what happened in the last clip. To do this, surprise, surprise, we have to look at how the RAM works yet again. So most game developers essentially split the RAM into 2 parts. One is called the static part and one is called dynamic. Within the static part, all the boxes always remain located in the same place. It's called static because those boxes never move. They're always in the same place. And for this reason, in level 1, 2, and 3, no matter how many times we restart the game, the boxes is always in the same exact spot. However, in level 4, the value was stored in the dynamic part. And unfortunately for us, most games store most values within the dynamic part. This means that we would technically have to look up that value every time that we restart the game, which is very inconvenient. However, lucky for us, there are tricks to avoid this. What we're gonna do is try to find within the static part a box that tells us where the value really is within the dynamic part. So we want a box that holds some sort of information about where the box we're looking for is within the dynamic part. And lucky for us, that box can pretty much always be found. Okay, so now let's figure out how this mysterious box really works. This box is called a pointer, and it's called a pointer because it points to another box. And the way a pointer works is that every box within RAM is given an address. An address is simply a number that allows us to locate every box within RAM. Now, the pointer simply holds the address of the ammo, or whatever value we're really looking for. In this case, is the ammo. So, once we have the pointer, what we have to do is look inside the pointer, look at the address, navigate the RAM until we find the address that we care about, and that's where the box will be. Now, it's really important to remember also that this pointer is stored within static memory, which is very useful because once we find it, we never have to look for it again. On top of this, if the ammo is allocated to a new box, so it changes its place within the dynamic memory, the pointer will be updated and will have the new address of the new box. And thanks to this, all we have to do then is find the pointer once, and then we basically find the ammo forever. Okay, great. So, until now, we've covered the difference between static and dynamic memory, and we've also covered the topic of pointers and addresses. I want to emphasize that pointers are one of the hardest topics to understand within video game hacking. So please don't feel bad if this still seems confusing to you. You'll see, as we go along and as you see it more and more, it will start to make more and more sense and it will start to clear up. From now on, all we'll be covering in this video is a few little things that will show up as we use Cheat Engine to find pointers. The first thing we'll cover is something called offsets. Offsets come up because Cheat Engine won't always be able to find a pointer that points to the exact box that we want. Instead, it will point to a very nearby box. In this case, the box that we want is nearly the same as the one that the pointer holds, except that it ends with a 0 and we want the one that ends with a 4. In order to compensate for this, Cheat Engine will provide us with an offset. In this case, it will be the number 4. And the offset is simply a number that will add on to the address in order to compensate for the pointer not pointing to the exact box that we want. So by adding the offset, we compensate. That's it. That's what offsets are. So we finally reached the last step of this class, which is called pointer chains. Essentially, up until now, we've covered the case where we find a pointer that immediately points to the value that we care about. This occurs rarely. What most often happens is that a pointer will actually point to another pointer, and this pointer may actually point to another pointer again, and this will build a chain where one pointer points to another. And this will continue and continue up until the last pointer actually points to the value that we care about. In the case on screen, there's 3 pointers and the last one is the actual value that we want. And each one of these pointers is again given an offset. The only thing that matters in the pointer chain is that the first pointer is actually within the static memory, meaning that we only have to find the first pointer once. And then all that matters after is knowing how many pointers and what are the offsets for each pointer to get to the end of the chain. So essentially, we find the first pointer, we look inside of that pointer, we look at that address, we add the offset, and this will point us to a new box, which would be a pointer. We apply the same process, so find the address as the offset, go to the box, and repeat this process up until we reach the end of the chain where we finally find the value. Although this looks like a lot of work, lucky for us, Cheat Engine will automate all of this. Anyways, let's see how this actually works within Cheat Engine. See you in the next video. Okay, so in this video, we're going to cover, at first we're going to cover a few tricks that Cheat Engine gives you that I haven't covered yet. And then we'll cover actually how to get those pointer chains we were talking about before. So let's head over to level 1 first, and I want to show you something. So if you look for the value here. Okay, so now we get the 2 addresses that it found. So again, one of these is the one that is real and one of these is fake. Nonetheless, what we used to do is go down here and see which one changes correctly, right? Now, what you can see here is that one of them is in green and one of them is in white. The one that is in green is the correct one because when it's written in green, it means that it's statically allocated. And we know that if I leave the level and come back, I still have the value correct, right? So like, I can still change this one to 100. In fact, you can see here how this one updates correctly and this one has been allocated somewhere else. So this one is dynamically allocated and this one is statically allocated, right? So that's what I want you guys to notice is that green text means static, white text means dynamic. And so preferably, you try to find a box that has green text. Of course, this one doesn't always exist, but in level 1, 2, and 3, the box is in fact static, so the text will be written in green. So that's what I wanted you guys to notice. Now, I also want you guys to notice that this one gives some address and this one has some text plus some number. And so what's going on here is that this is just the address of the dynamically allocated box. And this one is the name of the process, meaning go to wherever in RAM the game starts. So which part of RAM is allocated for this game. And from there, go up to this many different boxes up until you reach the address. So this is like an offset. So it says go to the beginning of the game in RAM and sum this much in order to reach the box that holds the value. And so that's it. That's how you read these. So that's what's special about static addresses. They always start at the beginning and you have some sort of offset from the beginning in RAM up until you reach the box that is statically allocated. Okay, now let's head over to level 4. So click on level 4. And now we're going to look for the address again. So the first thing we're going to do is press 7. Yep, okay, cool. So we found the right address. Now, I want you guys to notice that they're all in white, meaning that the correct address is also dynamically allocated, right? So they're all dynamically allocated, even the correct one. And we know that if it's dynamically allocated, that means that if I leave the level and come back, it will have changed position and probably be in another box. So how do we find these pointer chains that we talked about in order to always figure out where this box is? In Cheat Engine, it's really easy. So it's simply right click and you'll have this option here, pointer scan for this address. Just click on it and you'll be given this massive box with a bunch of options. For now, just say, okay, these options are good enough. I'll cover what these options do in just a bit. However, just press OK and let's see what it does. The first thing it's going to ask you is to save the results of this scan somewhere. I'll cover what this file now will contain, but for now, just name it ammo pointer map.ptr. That's the name of the file. .ptr just stands for pointer. And I already have a file that I made, so I'm just gonna override it. But for you, you'll have to make a new one. So just say ammo pointer map or name it whatever you want. That's what I'm naming it. Press save. It's gonna ask me if I want to replace the one I already have. I'll say yes. And it's gonna start from the beginning. So now it's gonna do a pointer scan for the address that you're looking for. Now this pointer scan will take a very long time. And this specific scan may take a couple minutes. In fact, if your computer is slow, it will take a very long time. And you'll see how in more complex games, it can take even longer. However, we'll cover in just a bit as well how to speed this up. But for now, just be patient and let's see what it gives us. Okay, great. So on my computer, it took a little less than a minute. On yours, it might be faster or slower. However, don't freak out if it takes a couple of minutes. It's completely normal. So the first thing I want to do is just explain what we're looking at on screen right now. So every row here is a different pointer chain that leads to the address. So as you can see here, you have the base address, meaning the address that is within the static memory. And as you can see, it's specified the same way that it was specified over here. When it was static, you have the name of the process plus a number. And so it means go to the beginning of the process, add on this much, and then you will land on the first box, which will be the static pointer, so the base pointer. You'll add, then Cheat Engine will simply add this offset, look inside this new box, look at that address, add this offset, and so on. So follow the chain all the way up until the 7th jump, which ends here. And this will give us the value that we care about in the end. So what we're going to do first is click on offset 6. And this will sort to the list, and you'll understand in just a bit why I want to do this. It will essentially give you the shortest path first. So as you can see, the shortest path, and then it will increase as we go down. Now, some of these will be unstable. So as you can see, some of them have question marks, some of them have weird values. Not all of them remain pointing to the right address, right? So this is the right address, and you can see here that a lot of them are pointing to the right address. So it says it's pointing to this address, which is equal to the value 1, which is correct because we have 1 round, right? Okay, so in order to figure out which ones of these are stable enough to use, what we're gonna do is simply double click on a bunch. So if we double click on one, it will bring it down here. So I'm gonna ask you to just double click on a lot of them. So just keep going up until you have, say, around 30 of them. So you can also scroll down a little to get some further ones and keep scrolling down. Keep going. Okay, so now I have a bunch of them here. That's, I'm assuming, is going to be enough. Otherwise, we're going to have to do this again. But this should be enough. So as you can see, a bunch of them are unstable. They keep switching up. So all the ones that look unstable, just select them all and just delete them. So this one, 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 this one. Okay, so what I mean by unstable is all the ones that keep changing the address or change the number or show up question marks. All the ones that are not fixed, like this one, that it just stays and it points to 1. All the other ones, just delete them. So right click, delete these records. Yes. Okay, so now we have, oh, this one seems unstable too, delete it. Okay, so now we have all these that seem decently stable. Okay, there's still a couple that are not, but for now, whatever. This is good enough. So we have these that seem stable. So if we, in fact, if we increase the value here, so let's say we have 1,000 rounds, you can see they all update to 1,000. Okay, this one is unstable, delete it. Okay, now what we're gonna do is leave the level and come back and see which ones now have the number 7. So we can see that this one, this one, this one, and this one all fail to remain at 7. Okay, so now we can see that all of these are at 7. And you can see how the one that we found manually here is now still at 1,000. So this one now is invalid. So we can delete it. And you can go ahead and change this to, let's say, 1,000. And you can see how you have 1,000 again. Okay, so we found it again. That's good. So leave the level, come back, and it still updates. So we still have access to the correct box. Again, look at how the box completely changes now. It's a completely different box than the one that we had at the beginning, which is one of these. It's pointing somewhere else. However, as you can see, we always find the new box because we found the pointer chain, right? Now, we can also do something, which is close the game and reopen it. And attach to it. Say yes to this. And as you can see, if we go back to level 4, now this one is the only one that remains correct. So we got somewhat lucky. All these 4 are incorrect. So let's delete them. Okay. So now leave the game, come back. It still points to the right place. Close the game, open it again. Let's test it out one last time. Connect to it. Of course, yes. Level 4. And it still points. Okay, so now we have a reliable way to find the address. So we can make it 1 and make it infinite. And then we have infinite, we come back, and there you go. Right? So no matter how many times you leave and come back, this pointer chain will always be valid. So again, the step process is find the address manually, right click on it, say pointer scan for this address, say yes to the options, look at the massive list of pointers that pointer chains that it will find, select a bunch of them, try them out and see which ones remain stable up until the point that you are left with one or a couple that are stable. Then pick one of those, and that can be from now on the result that you have. So now you can name this level 4 ammo, and now you have it forever. So now you can leave, you can close the game, come back, attach to the process. There you go. Yep. And go to level 4. And as you can see, it's immediately made your ammo 1, and it's infinite. And so from now on, you have infinite ammo. You never have to search for the value again, essentially because you found a correct pointer chain that is very stable and always provides you the chain necessary in order to find the new box that is dynamically allocated. And so yeah, that's it. That's how you do it. Now, as you saw, it took a while, even though it's such a small game. It took a while to find the pointer chain, and it's also was difficult to find the correct pointer chain that we wanted, right? Because a bunch of them were invalid, and it was kind of lucky that we ended up with one pointer chain that was actually stable enough. So we're gonna cover a trick that we can use in order to guarantee a smaller list of more stable results. Okay, so as you saw in the previous video, we had a bunch of unstable results, and that can be very annoying. In fact, we got really lucky in the previous video where I ended up with exactly one stable result. And that is very inconvenient. And what we would like to do is have a significantly more stable list of results in order to not have to get lucky and remove so many manually and check if they're unstable multiple times. All that fluff and annoyance that we had to do, we're going to be able to make it significantly more stable and reliable. And the way we're going to do this is that we're going to generate 2 times the same scan data result for 2 different instances of level 4. It will make sense as I do it. But essentially what we're going to do is find 2 lists of pointer chains and then compare both lists to see which ones overlap. So let's go to level 4, and as I go through it, it will start to make more sense. So let's go to level 4 and look for the value again manually. So let's do first scan. By the way, as you can notice, I completely removed everything and pretend like we didn't do the steps from before in order to start from fresh. So let's do 6, next scan, 5, scan, 4, next scan. Okay, so now we have 4 of them. Let's see which one of these is correct. 1, oh, perfect. The first one was correct. We got lucky. Great. So now we're going to generate the results for the first one, but we're going to generate them in a way that we can compare with the next scan that we'll do. So right click on this and sorry, not right click, but double click and name this ammo1. Okay, now that we gave it a name, this will be important for later. It's useful to have a name on this one. Right click on it, and instead of clicking pointer scan for this address, just click on generate pointer map. Once we do this, it's going to ask you to save the file somewhere. In fact, this file is going to be slightly different. It's going to be a scan data and not a .ptr, but for now, don't worry about the difference. Just name it ammo1 scan. Okay, so now it's going to scan, and it will save the results to the file directly, and it won't show us anything when it's done. So just be patient. Again, this can take a few minutes. Okay, now we save the pointer map, and what we're gonna do is leave the level, close the game, open it again, attach to it again, yes, go to level 4, and now we're gonna look for the value one more time. Now, we're gonna do directly a pointer scan for this address. So until now, it's gonna be the same as we did in the previous video. So pointer scan for this address. And now we're going to click here where it says compare results with other saved pointer maps. So click on this, and it will open this little menu, and it's going to ask you to locate the scan that you want to compare with. So click on this one, and then select the address that you want. So click on it, and you'll see that it's going to have the address equals and the name that you gave it. This was important to give it a name in order to find this quickly. So we know that we named it ammo1, so click on ammo1. So again, what it's going to do now is do a pointer scan for this address, but compare the results for the pointer map that we generated before. And essentially, it's creating the same results twice and comparing which results overlap. So which ones were valid in both instances of the game. And this will get rid of a bunch of unstable ones. So all the ones that don't show up twice means that as I restarted the game, those pointer chains were incorrect and they died off and they changed to something else. So by comparing, we can remove all of those. And this is why it becomes significantly more stable. So just press OK. And then generate the PTR file somewhere. So ammo pointer list, let's say, and generate it. Now, as you can see here, it's comparing with the .scan data file, and it's generating the pointer map for this one. So now let's just wait a little bit. Okay. So now I didn't mention it before, but here on top, you can see the amount of results that you got. And here we have 170,000 results. But if you looked at the previous time when we directly did just the pointers scan for this address without generating a pointer map before, you'll see that we had roughly like 3 million, I believe, results, which is a lot. Now we only have 170, which is much better. Now let's do the same thing that we did. So let's click on offset 6. This is going to sort them. As you can see, it sorted them much faster because there's so few of them. And now let's do the same thing. Just double click on a bunch and let's try them out. So this one, this one, this one, this one. Go down a little more, a little bit more. Go down with the cursor here. Select a couple more. Okay, so now we have a bunch of them. And as you can see, we still have some unstable ones, but you'll notice that a lot more of them are stable. So let's delete this one, this one, and this one. Great. Now, now they all look stable, except these two. This one. Okay, great. So let's remove these. Okay, they all look somewhat stable. They all seem to work. We can remove the additional ones that are unstable. Delete them. Okay, now let's close the level, come back, and remove the ones that were unstable then. Okay, again, same process. So delete these. Okay, still works. Now let's close the game and come back. So attach again. Say yes. That's level 4. And you can see that, oh, wow. Okay, so they all worked after the game restart. So all the ones that we found worked. So as you can see, we instead of having only one like we did before, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay, we have a bunch of them, right? We have way more. And now, if you want to get really, really stable results, you essentially create like an ammo 1 and then generate pointer map. Then generate ammo 2, generate pointer map. Ammo 3, 4, 5, as many as you want. And the more you have, the more stable the results will be. And so, but usually just one pointer map and then directly pointer scanning and comparing is enough. So just generating 2 results is usually sufficient. But you can do more if need be. So you'll see in the situation that you find yourself in, you might need to make more pointer scan searches, more pointer maps to compare with. But anyways, that's the trick. The trick is to generate multiple results and allow Cheat Engine to compare the two lists of results in order to find the most stable ones. Now that we do this, of course, you can just freeze any of these and they will be stable. Now, let's say I'll just take the first one for the sake of it, delete all these, and then freeze it. Name it again to level 4 ammo. Delete all of these. And now finally we can win at this level. So let's finish all the boxes. All right, great. We finished the game at the level, and then it's gonna bring us back to the main menu, and then we can go back to level 4, and we immediately have infinite ammo again. Great. And yeah, that's it. So all I wanted you guys to understand that is different from this level, this technique from the previous one, is that we generated another pointer map to compare the results with in order to eliminate a bunch of unstable results. So by doing this, we get significantly more reliable results, and the more pointer maps that you generate, the better. So again, just to point out, if you try to do a pointer scan for an address, you click on compare results with other pointer maps. And then here you can just add more and more of them. So we can do this one, and you can add another file, which I don't have, but let's just pretend that I did. You select the address that matches, and then you'll be able to get significantly more reliable results. So here you can put as many files as you want. Okay, so now I just want to point out a couple options that you get when you click on pointer scan for this address. You get this menu, and I just want to clarify a few things here that might be useful for you later. So the first thing is you are already aware of compare results with other saved pointer maps. That's what we did before, to compare and get more valid results that remain stable. Then we have this here that says generate pointer map. If you click on this, it's identical to right-clicking and clicking generate pointer map. And then we also have these two here. These two numbers can be useful as well. So these are the default numbers. And what they mean is, so max level is a total of how many jumps do you want Cheat Engine to look for. So it's set to 7 as default. So as you saw, we had offset 0, 1, 2, 3, 4, 5, and 6. That's a total of 7 jumps. And now you can reduce this in order to get smaller lists, but you might skip a lot of valid pointer chains. So we're gonna try doing 2 because I know the putting 2 works, and you'll see how few results we actually get. So I'll save it as ammo pointer list -2 levels and just press save and say yes. So let's speed this up so that I can show you the results. So once it's done, you can see here that we get a total of 3 different ones. And I just want to point out that as you can see, it has offset 0 and offset 1. That means that we jump from the base address, we add the first offset, we jump from that new address, we add the offset 1, and then we end up on the value. So we do a total of 2 levels. Now you can see that we only get 3 results instead of the millions that we were getting before. And in fact, one of these is actually correct. I just want to show it to you because I thought it was cool that doing only 2 works. So we can see this one doesn't. And then if we leave the game and come back and attach again. So of course, there you go. Say yes. And go to level 4, and you can see, in fact, they both seem to be working properly. Actually, no, this one died. Cool, perfect. So this one is the one that works. In fact, I believe this one and this one are identical. Nonetheless, I just want to point out that you can reduce the number of levels in order to make the list shorter. However, you will end up with fewer results, which means that you might miss a correct result. And in fact, most times only 2 levels isn't enough. That's why the default value is 7. I recommend strongly to leave it at 7 unless you see a reason to lower it or increase it. So mostly increase it if you can't find a stable pointer, and decrease it if you want a shorter list because it's convenient and you believe that in a shorter list you'll still be able to find some stable pointer. So that's it. I just wanted to point that out. So right click and delete this record. Say yes. And now we're gonna go to this one here that says maximum offset value. The bigger it is, the slower the Cheat Engine will be at computing at searching for pointer chains. So if you reduce this number, you can increase your chances, increase the speed of this process, but you will lower your chances of getting a correct results. So if you're struggling in finding correct results, you can increase max level. So it defaults at 7, so you can make it 9. And if you're also struggling, you can increase the offset value. So those are the two main tricks in case you are struggling to find a pointer chain that is valid. And so that's it. Okay, now I just want to point out a little detail. Up until now, I've used the term box. However, now that we know what addresses are, I want to tell you that when you go outside of this course, you won't hear the term box. You'll only hear the term address. I want to point out that box and address are the same thing. A box is what I use to refer as a place in memory that holds a number. Now, instead, we're going to use a technical term that is an address. So the address is simply the number that points to a place in memory that holds a number. So it's identical to a box. It's just a term that I use to simplify the explanation. But from now on, you have to know that the terminology changes and we're going to use address because address is the correct and more professional term to refer to a box. Okay, now I want you guys to use this new knowledge about pointers in order to do an exercise essentially and practice. And so I'll give you a few tips for this, but after that I'll let you on your own, and then whether you succeed or not, no worries, I'll show you how I would do it after you've tried it yourself. So go on level 5 here, and then it says on the left, for this challenge you must get across the surface in order to reach the other platform. The red surface will damage your health bar shown at the bottom right. Now you currently have 10 health, but if you walk, you'll see that you'll start getting damage and you won't get to the other side. Some people will try to jump to try to get there, but this won't work either because although you might get a little further, you'll still die without reaching the other side. Now, what I want to show you is that if you try scanning now, you'll go down here and you'll start taking damage, and it will take damage way too quickly in order to like move to cheat engine and look for the value and do all the scanning manually. So let me restart again. So what you can do is go here on the right where it says settings, and it'll start like this. It will look like this for you. Go on the left where it says hotkeys, and then here it says pause the selected process. Click on it and then give yourself a hotkey. So you can press Q. That's the one I gave myself. You can choose any key that you want on your keyboard. So it will be like this, and then you can press Q and press OK. Once you do this, you can freeze the game. So you can walk on the thing and press Q, which will completely freeze the game. You'll see here that it says paused. So now you can look for the value, do the next scan, then go back into the game, press Q, take some damage, press Q again. Now you can search for it again, and so on. You can do the search as you would typically do it. Once you do, you find them, you can update the values, which will give you a lot more health. So there you go. Now, the other thing I want to point out is that if you update the value here, so let's say to 1000, it won't show up on the bottom right up until you take damage. Okay, so in order to find which one is the correct one, you have to give yourself, let's say, enough health on this one, take some damage, see that it didn't work, so that's not the correct one. Delete this one. Now you can give yourself a lot more here. Go here, and now you take a bunch of damage, but you'll see that you have the health. So you have to take damage for the display to update, but the value still works. So that's it. Now don't forget, now you can right click, generate pointer map or pointer scan for this address. Use whatever technique you want out of the ones I showed you before. And so that's it. I'll be right back once we're done, and I'll show you the solution. Okay, so let's look at how I would solve it. So let me start from the beginning, go to level 5, and let's search for 10. So first scan. Now let's take some damage. 8, next scan. Take some damage again. 7, next scan. Cool, we only get just 1, that's awesome. Give ourselves some health, see if it works. It does. Let's rename this to health 1, and let me do a pointer map for it. So let me call it health 1 pointer map. You can call it health 1 scan or whatever file name you want. I'm gonna speed this up so that you don't have to wait through all this. Okay, So now that we have that, we can leave the level, come back if we want, or we can completely close the game. A little more robust. So let's do that. Click on this, on beginner course, say yes, go to level 5. And now let's do the same search. So 10, new scan, first scan. Okay, so 10, take some damage. Now we're at 9, next scan. We're at 8, next scan. And now we have 2. I'm assuming the, oh, no, this one actually doesn't work. So we know it's this one. Let's increase it. 1,000, great. So now let me pointer scan for this address. And let me compare the results with another saved pointer map. I'm gonna click on this one, and provide the health 1, and press OK. And now let me save this somewhere. So health 1 pointer list. Okay, so we have 63 paths. That's pretty good actually. Let's see which ones are the shortest, just for the sake of it. Let's try them all out, see if this actually works. Yeah, let's see if which ones remain correct once we come back. So this one we can delete. This one are all invalid. Let's delete them. Let's close again just to make sure. Yep, those work. Close it. Let's open the game again. Attach. Say yes. Go to level 5. Oh, this one failed. Let's play around a little bit. Oh, this one game point question marks for a split second. We can try just locking this to 4. Walking across. You can see sometimes it drops to 3 because the game is continuously trying to remove health, and cheat engine is trying to keep up and put it to 4 all the time. You can go back to level 1 just to mess around with it a little more. Go back to 5, see if they're all still stable. They are. Great. So any of these work. So let me delete all of these. Delete these records. Yep. And now let me rename this to level 5 health. Okay, and then that's it. Now you can give yourself 1,000,000 points of health. Go in, and now you have full health. Great. So now, if you have at all any struggles related to achieving this, don't worry. It's normal. You can just restart over and over again until you get it right. You don't even need to do the pointer map, I don't think. I haven't tried to just do the pointer scan directly. It might be slightly more difficult, but it should still work. Again, this is one of the hardest topics to get right. So please be patient with yourself. If you have at all any trouble, it's completely normal to get stuck on this. But there you go. That's how you solve this one. And I'll see you in the next episode where we start doing code injections, which is by far the coolest way to hack video games. So, all right, I'll see you soon. Okay, so now we'll cover something called code injections, which is by far one of the coolest ways to hack a video game. Instead of changing values within the RAM, what we'll be doing is actually changing the logic behind of how the game really works. To do this, we'll have to understand how the CPU works and what it really does. Essentially, game developers give instructions to the CPU in order to run the logic behind the game. For example, when you click on the mouse button and you shoot a round out of the weapon, what it's really doing is asking the CPU to first check if you've actually pressed the button. If you have, then create the round and throw it out of the weapon. And once it's flying, apply gravity to it. And a million other things. For example, checking if the bullet actually collides with one of the boxes and making the box disappear, and adding points to your points if you've actually destroyed a box, and so on. There's millions of things that the CPU has to do every second in order to keep the game running. Now, although I said that the CPU takes care of very complex tasks, in reality, it can only do some very basic operations. For example, it can do basic math like sum, divisions, multiplications, subtractions. It can also compare some values, like tell you if a number is bigger than another one, and it can also move some data around, like changing the values within some boxes. Now, although it does very basic operations, it does them very quickly, like billions of operations per second. For this reason, although the operations are very basic, if you add billion of these operations, you can actually achieve very complex tasks. And this is the reason why the CPU can actually run complex things like video games. Awesome. So now let's actually have a look at how we can provide operations to the CPU. These operations are written as instructions, and they're actually written in something called the assembly language, which is the only language that a CPU understands. You can have a look on the right at what it actually looks like. However, I know it looks weird and cryptic, and I promise very soon it will start to make sense and you'll be able to write in this weird language in order to build your own hacks. Okay, great. So now that we know this, let's check where all these instructions are actually stored in order to go there and change them. Now, surprise, surprise, these instructions are obviously in the RAM as well. Now, the RAM is actually split into two parts, the data part and the instructions part. The data part is where we've been working on the most up until now. In fact, it's the only part of the RAM that we've actually touched. And that's exactly where the static and dynamic areas that we talked about before are. Now, if we look at the instructions part, you'll see that it's again just a bunch of zeros and ones split into boxes. Each box has its own address. However, the boxes, instead of holding numbers per se, they actually hold assembly language instructions. These assembly language instructions are just a different way to interpret the zeros and ones, and these zeros and ones can basically also be turned into numbers if you would like to. All I want to point out is that these instructions are stored the same way that numbers are stored. There's nothing special. And so that's it. We're just going to go look at the instructions part within Cheat Engine, and from now on, we'll be able to have a more hands-on approach for the rest of this topic. Okay, great. So now that we understand a little bit more about how the CPU works and what assembly language is, we can get started on our first code injection. For this, we're going to head to level 5 for the most basic example. Now, up until now, when we wanted to finish level 5, we will go into the data section of the RAM, we would find the box that holds the health, and we would mess around with it, right? So, sorry, I completely forgot to attach the process, so let me do that first. Okay, so here we can see that we have level 5 health, we have the box that holds the health, and then we can go here and mess around with it, give ourselves a bunch, and then when we go inside the red section, we have enough health to tolerate the damage, or we can also freeze it, right? This is the other strategy we were doing, so freeze it completely, and walk around, and there you go. That's all we were doing. Great. Now, what we want to do now instead of messing around with the box of the health, what we want to do is mess around with the logic of the CPU, right? Now, the logic is when you touch the red box, decrease the player's health. That's what the CPU is doing, okay? So it checks that you're touching the red zone, and when you are, it decreases your health. Now, what we want to do is find out which line of code is actually reducing our health. So which line of code is doing health -1. And when we find that line of code, what we want to do is just disable it completely. So just disable that line in order to remove the logic that reduces our health when we touch the red surface. Now, in order to find that address, that line of code, what we're gonna do is head over to Cheat Engine, over here, and then we're gonna right-click on the address here. And it's gonna say, we're gonna have two options that we can look at. We can find out what accesses this address, or find out what writes to this address. Now, find out what writes to this address is the one that we're interested in. Writes means find out which lines of code are modifying the value inside this box, right? So we want to find which lines of code are affecting the number here. Currently, there's only one line that affects it, which is the one that when we touch the red box, it reduces our health. So let's click on that. And it's gonna say, do you want to attach the debugger of Cheat Engine to the current process? We're gonna say yes, because the debugger is just the tool that Cheat Engine uses to inspect the assembly language as we play the video game. So we have to say yes to this in order for it to actually inspect the assembly code. So say yes. And now, specifically because we chose a pointer, so this wouldn't happen if we chose a normal address, it's gonna give you two options. Now, the second option is the one that we're interested in. It's gonna say, find out what writes the address pointed at by this pointer. So what it's really asking is, would you like to look at the assembly code that affects the value over here? The other option here is asking you, do you want to see all the assembly code that affects the address here? So whether you want to know where the pointer points to, or whether you want to know what the pointer points to holds, like the data that it holds. We want to know what affects the data inside. So that's the second option. We're going to click on that, and it's going to pop up this window. Now, this window is going to show you all the lines of code that have affected your health. So we're going to go and take some damage. And you can see here that this line of code has appeared. Okay? And it's going to say over here, there's the number 13, and it says this line of code has executed 13 times since we've opened this window. And it makes sense because we took 13 points of damage. And this line of code is over here. The part that we're interested in is the one on the right here. So this is the actual assembly code. The part on the left here is just the address within RAM where this instruction is actually stored, but we really care about what the instruction is actually doing. Now, this instruction is DEC. It stands for decrement, which means basically -1, so reduce by -1. And this RCX over here will talk about why this actually means health, but essentially what it's doing is decrement what's inside RCX, which is the health in this case. Don't worry about how RCX works, we'll talk about that later, but for now just focus on DEC, which stands for decrement, which is -1. Okay, so just to reiterate what we did. We asked Cheat Engine to give us all the lines of code that affect our health. When we asked for it, it gave us this one line. So now we have the line of code that affects our health when we touch the red surface. Now, Cheat Engine allows us to do something really cool, which is if you right click on it, it's going to give you the first option, which is replace with code that does nothing. If you press on this, it's going to pop this little window out, which is just a way to name this address, this instruction for later on. So for now, just press OK. It doesn't matter. And when we touch the red surface, you'll see that we take no damage. So what's going on here is that we found the line of code that reduces our health. And once we found it, we told Cheat Engine to replace it. So this is essentially a very basic code injection, which is just replacing that line with instructions that do absolutely nothing. And so every time that the game tries to damage our health, it meets an instruction that does nothing, and so our health is unaffected. And that's it. That's our first code injection. Now, you may be wondering where this code injection is, right? Where can you modify it? Because over here we have all the data that we have, but we don't see anything related to the code injection. The code injection is actually here at the bottom where it says Advanced Options. If you click on it, you'll have the actual code that you modified. If it's in red, it means that you've disabled it or that you modified it. The red is modified, and if you right click and click on Restore with Original Code, it will turn into white, and this is restored to its original state. So if we go and take some damage, you'll see that we take damage for as long as this is white, and then when we right click and click on Replace with Code that does nothing, we again freeze it again, because essentially we are disabling the code that reduces our health. So the code that reduces our health doesn't exist anymore, at least according to the CPU and the video game. Okay, so that covers the most basic version of code injections. I hope this was somewhat clear. I promise as we go along, it will start to make a lot more sense, and as we see more examples, it will start to complete the picture within your mind, and you'll be able to do this on your own. For now, I just wanted to point out that we have access to this very cool tool that is code injections, that we can actually modify the logic of the game. Now, one last cool thing about this is that, as you saw, it didn't take much time to modify this line and make our health infinite. And in fact, not only is it quick to do in comparison to finding pointer chains, when you quit the level and come back, you'll see that, again, your health remains unchanged. So you, again, have infinite health. So the reason why is because instructions are saved within the instructions part of memory and not within the dynamic part. So these instructions always remain in the same exact place. And for this reason, we only have to find them once, and then we can always revert back to them. And so that's it. That's code injections, the most basic version at least. And from now on, we'll start adding up onto this up until we get to some slightly more advanced stuff. Okay, so now I would like you guys to use this knowledge to hack level 4 using entirely code injections instead of using the pointer chains that we used before. So let's go to level 4. And we know that if we shoot, we lose ammo. So now I would like you guys to try making a basic code injection in order to give yourself infinite ammo. And then I'll be right back with the solution. Okay, so this is how I would do it. So we already know where the ammo is. It's here. So first of all, let me attach to the process. Yep. Now right click on it and click on find out what writes to this address. Say yes. Click on the second option. And now let's choose. This will show this line. I'm going to click on it and I'm going to right click and click on replace with code that does nothing. Go over here, press OK. And then when I shoot, I don't lose any ammo. Great. And then you can simply go into advanced options to revert this back to how it was. Then right click on it and then replace with code that's nothing again if I want to have ammo again. So let me reset my account. There you go. Okay, so in this video, we're going to do something slightly more complex. So up until now, what we did is find lines of assembly code that we wanted to disable and we replaced them with lines of code that do nothing. This time instead, we're going to replace that line with code that does something completely different instead. So let's go to level 5, and when we touch the red zone, we know that we lose health. What we would like to do is instead of lose health, we would like to gain health every time we touch the red zone. So what we're going to do is we're going to go into health and we're going to do the same stuff, right? So we're going to do on find out what writes to this address, and we're going to click on find out what writes to the address pointed at by this pointer. We're going to take some damage, and then this line will show up, and you can right click on it and click on show this address in the disassembler. If you do, this window pops up. Now I want to point out that you can also just go into advanced option if you already have it, and you can right click on the line and click on open the disassembler at this location. It does exactly the same thing, it just opens this window. So what this window is called the memory viewer. Now it's called a memory viewer because what it does is it allows us to look inside the RAM. So again, remember RAM and memory are basically synonyms. And the bottom part here is all the data section. So here you can see all the data. I'll explain later on how to read this. For now, let's completely ignore it. And we can look at the top part, which is the instruction section. Oops. All right, there you go, perfect. Now, this one here that is highlighted in blue is the line that we're interested in modifying. So we know that it's DEC and then in brackets RCX. Now, if you double click on it, this window pops up, which is called the single line assembler, which essentially allows us to replace this line with whatever we want that we write in here. What we're going to write instead of DEC, we're going to replace it with INC. So keep the brackets and the RCX intact, just change DEC for INC. Now, what INC is the opposite of DEC. So DEC is decrement, so -1, and INC is increment, so +1. So now if we press OK and we close this, we can see that when we go and touch the red zone, instead of taking damage, we gain health. So that's awesome, right? So now we have this infinite health pool of red. Instead of it being a thing that hurts us, it heals us instead. So that's it. That was the most basic version of code injection, except for replacing code that does nothing. Now, I want to also point out that when you start messing around with code injections like this, you can start modifying code in random locations, right? So if I go here and I start writing code here and I change lines at random, I may start to mess up the game way too much to the point that it becomes unplayable. Now, I just want to point out that if you want to reset everything to how it was, so remove all code injections, let's say that you replace this with code that does nothing, just press yes, then change this one as well. Let's say they're both red and I would like to, and let's say we had 100 more and we want to change them all back to normal. It's very easy to revert all code injections back to normal. You can just close everything. So close the game, close cheat engine as well if you'd like. This is not necessary, but what you do is open the game again, open cheat engine. And as soon as the game closes and reopens again, the RAM will be refreshed to the initial game instructions. So all the instructions will be set back to default. So once you connect again, to beginner course, say yes, you'll see that they're all in white. And if you go and inspect at the disassembler, it's back to the line that it was before. So essentially, all I want to point out is if you close the game and open it back again, everything gets reset to its default values. And so that's it. All right, in the next video, we'll start actually writing a lot of lines of code to create significantly more complex features. And I'll see you in the next video. Okay, so in this video, we're going to cover something called hexadecimal numbers. Now, you probably saw when we were looking at addresses that addresses are written in a weird way. They have numbers and letters within them. So let's look at what those letters really are. So the first thing we have to look at is how binary works. So if we look at 4 bits of binary, you can write between the number 0 and the number 15 using only 4 bits. So here on screen you can see how to write each one. So this is how to write 0, how to write 1, how to write 2, 3, 4, 5, 6, 7, 8, and so on up until we reach 15. There you go. Cool. So as you can see, we can write a total of 16 numbers, so between 0 and 15. And here on screen you can see them all. And what I want to point out is that hexadecimals are used in order to take a massive binary number and condense it down into few characters. So the first thing that they did is take the numbers 10 to 15 and replace them with letters. So as you can see here on screen, you can see that the number 10 became the letter A, the number 11 became the letter B, and so on up until F, which represents the number 15. So now that we have a single character for each one of these numbers from 0 to 15, we can take a binary number, like the one above here, and take each one of those groups of 4 bits and change them for a hexadecimal number. So the first one here is 10, so it becomes an A, the second one here is a 2, the third one is an 8, and the third one is an E. So now this massive binary number becomes A28E, which is just 4 characters, and it's much easier to write. So again, we took a 16-bit number and turned it into a 4 hexadecimal number, which is much shorter and much easier for us to use. And I just want to point out that the reason why we came up with hexadecimals is because it's much easier to translate between binary and hexadecimal, because we can just take chunks of 4 and translate each binary to hexadecimal. Whereas if we wanted to use regular numbers, so base 10, we would end up with this number, which is 41,614, which is really hard to see how the binary number becomes this decimal number. So that's why we have hexadecimal numbers. So again, all I want you guys to get is that we just took 4 bits together and we assigned a number or a letter for each sequence of zeros and ones, and then we can write down binary using hexadecimal instead, which is much shorter. Okay, so it's just a way to write binary without having to write actually zeros and ones and a bunch of them. Okay, so it's just a way to write everything shorter. That's it. That's what hexadecimal numbers are. Now, later on, we might find ourselves in a position where we actually want to transform between decimal and hexadecimal numbers, or binary to hex. And here's a quick way to do this. So if you open the standard calculator that comes with Windows, and you click on the top left over here, and you click on Programmer, you'll get this window. And then let's say that, so if you click on decimal, you'll be able to write a regular number. So if here we write 41,614, which is the number from before, you'll get the translation in hex, which is 828E, and you'll get the binary number, which is 1010001, blah, 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 blah. Okay, so I just want to point out that the calculator of Windows allows you to do this quickly. And also, if you click, let's say, hex, and then you click A782, let's say, it gives you what the decimal number is and what the binary number is. Okay, so now let's have a look at an example where we have to deal with hexadecimal numbers. So let's head over to level 1 and hide the instructions. And now we're going to right click on level 1 points and click again on find out what writes to this address. So again, what find out what writes to this address does is give us a list of all the lines of assembly code that affect the value of points, right? So the value over here inside this address. And these lines will only appear here once they're executed. So to actually execute one of those lines, we have to change the points. So let's shoot a box, and then this line appears. And let's have a look at what this does. So click on it and click on show disassembler. And now we have this line right here highlighted. Now, if I double click on it, I want to point out that it will change slightly. So you'll see that this entire green part now becomes this number over here. So this number here, right? And what I want to also show you is that this number here is the address of the level 1 points. So what it's doing, it's saying add 05 to the value inside the address. So remember, the brackets mean go to wherever that box is in memory and change the value, right? So it's saying add to the box at this address 05. Now, it also has this dword PTR. So dword PTR, so it stands for 32-bit. And the way that this means 32 bits is that word means 16 bits. So a word is a 16-bit number. D word is a double word, so 16 times 2, that's 32 bits, and PTR means that it's a pointer, so it says add 05 to the 32-bit pointer held at this address. Don't worry why we actually have to write the word PTR, this is just some technicalities. All I want you guys to understand is that this command is the add command that adds 5 to whatever is on the left side here. Okay, so there's a comma that splits this side from this side, and it's saying add 05 to this thing. Okay, and this thing stands for 32-bit pointer at this address. Okay, so that's it, that's what it does. Now let's see how we can use this information to hack this video game in order to easily win. So let's try first to change the number of points that we win per box from 5 to 10 instead. So every time we shoot a box, I would like to win 10 points. So let's change this to 10 and press OK. Now once we do, we shoot, and as you can see, we went from 5 to 21, which is a 16-point difference. So you might guess that what happened here is that instead of writing 10 here, we wrote 16, and that makes sense because this number is hexadecimal. It's not in decimal. So if we head over to the calculator of Windows and we go top left and click on Programmer, as we did before, and we type in the number 10, we get hexadecimal A, right? And if we instead write 10 here, we get 16 in decimal, right? So what we're doing is writing 10 in hexadecimal and giving ourselves 16 points per time that we shoot a blue box. So what we want to do is click on decimal and write 100, let's say, and see what number we get. So hexadecimal 64, right? So so we know that in hexadecimal 64 equals 100. So let's try changing this over here to 64 instead. So press OK, head over to the game again, shoot, and as you can see, every time we shoot a box, we win 100 points. And so there you go. That's how hexadecimals are used within, at least one of the ways that hexadecimals are used within assembly code. And this is how the add instruction works. So it's add something over here, and then the value you want to add to it. And this value over here, really what matters is this part that says the address where we want to add this value. And this is just a technicality that for now we won't care about. Just know that it means 32 bits. So that's it. That's all it does. Okay. See ya in the next video. Okay, so now we're going to look at something called registers. Now, registers are exactly the same as the boxes that are inside the RAM, but instead of being inside the RAM, they're actually inside the CPU. Okay, so these registers, again, just boxes that instead of being in the RAM, they're in the CPU, and just to make the difference, we call them registers. And these registers, actually, instead of having addresses, they have names. So here on screen, you can see some of the names that we use to refer to them. Don't worry, you don't have to memorize this. I just wanted to point out that the names look like this. They're very short, a couple letters. And let's see how to actually use a register. So let's pretend that the register named RCX holds the value 10. And we want to apply decrement to RCX. So DEC RCX. Essentially, what happens is that when DEC RCX executes, it goes inside RCX and changes its value as expected, and that's it. As expected, the value inside RCX changes to 9, and there you go. That's how to use a register. It's just a box that has a name, and we can use operations on those boxes. Now, we're going to look at another example that is just slightly different. This example is the same, but RCX is within brackets. We actually saw this before. We saw this when we were giving ourselves infinite health when touching the red zone. This was the command that was decreasing our health. And I told you guys to ignore what brackets RCX meant because I was going to cover it later. And the moment has come. This is when I'm going to explain what brackets RCX is. So in this case, RCX does not hold your health. In reality, it holds the address to your health. So the address inside RAM holds your health. And the brackets say to the CPU that RCX is not the value you want to change. RCX holds the address of the value you want to change. So the brackets essentially tell the CPU to use RCX like a pointer, and that points to the value we care about. And when it gets there, it can actually change the box inside RAM. So instead of changing RCX this time, we're going to change the value inside the RAM. So changing the value from 10 to 9, just the same as before. So again, the difference between brackets and no brackets is that no brackets affects the register directly, and with brackets we affect the box that the register points to. Okay, so now let's have a look at registers. So for this, let's head over to level 5. And now head over to advanced options here down to the left. And you'll have here the command that affects your health, right? So when you touch the red zone, this line decreases your health. If you don't have it, don't worry. Just right click on the level 5 health over here. Click on find out what writes to this address as we've done before. Say yes to the debugger. Click on the second option. Once this window pops up, you can take some damage and this will show up the line that we care about. Now what you can do is click on it and click to add to code list. Once you do, if you didn't have it already, it would simply add it back to advanced options. So now that we have it, let's right click on it and click on open the disassembler at this location. And once we do, we'll have this window here. Let me just make it normal. Okay, so you'll have the line that we care about highlighted in blue. And what we want to do is see what the RCX register over here holds when this line executes. So what we can use is something called breakpoints. So currently I have this menu over here that is open. You may not have it. I'll cover how to get it open in just a sec. What you can do is click on toggle breakpoint, and this is going to tell Cheat Engine to stop the game right before executing this operation, so that we can look at RCX right before this operation executes. So either click on toggle breakpoint over here, we'll turn it green like this. The other option is to click on the debug drop down menu here and click on toggle breakpoint, or you can click on the view and click on show debug toolbar. So if you don't have it enabled, you can click on show debug toolbar and this will show up. So let's turn it on, make sure it's green. If you unselect the line, it should be completely red, so only when you touch it that it should be green. And now let's take some damage. So this freezes the game and displays to the right here the registers. Now on the right here we can see the RCX register has a value, which is this one. If you double click on the RCX entry here, you can edit the value, but I don't want to edit the value. I just want to show you guys that this number is identical to the address that is pointed at by the pointer chain of level 5 health. And this makes sense because this has to be the address of the health, so that DEC affects the value inside the box of the health, right? So it has to hold the address, and then with the brackets, it goes into the box and affects the value inside. Okay, so that's it. That's all I wanted to show you, is that we can use this toggle breakpoint option in order to affect, in order to pause the game and to have a look at the registers directly. And this can be very useful later on, as we'll see in the next video. We'll do some more complex stuff with breakpoints. Okay, so now in order to make more complex scripts, we're going to need to know a few more instructions. So in this video, I'll try to cover quickly the most common ones that we're going to be using. Now, the first instruction we're going to talk about is the move instruction. In fact, there's 3 move instructions. There's MOV, MOVSS, and MOVSD. Now, the only difference between all 3 is the type of number that we're going to be dealing with. So the first one is for integers, the second one is for floats, and the third one is for doubles. Again, remember, floats and doubles is the same thing. It's just that one is 32 bits and the other one is 64 bits. Regardless, the move instruction is going to take 2 arguments, the first one and the second one. Essentially, all it does is take the value from the second box and put it inside the first one. So as you can see here, the value of the second was 100, and after the operation runs, the first one is going to contain 100 as well. And the first and second arguments can either be registers or brackets containing addresses. So it can be one or the other, flipped or not. This is the most common way to use the move instruction. All it does again is put whatever was inside the second box inside the first one. So it moves the value from the second into the first. Now, we already saw the add instruction before when we were hacking level 1 with code injections. And I just want to point out that, first of all, there's 3 of them. There's the normal add, there's add SS and add SD again. And again, it's the same thing as the move instruction. We have the integer, the float, and the double. Now, the add instruction can take, again, the first and second arguments, and typically, although this is not the example that we saw before, it's going to be an address and a register, or a register and an address. It's kind of rare that we see directly a number used with the add instruction. Usually is going to be a register and an address. And now the result of the add instruction is always saved inside the first box that is mentioned. So if for example, in this case, the box holds 44 and the second box holds 100, after the operation runs, the first box will contain the number 144. Okay, next up we have the min instruction. Again, this one has a float and a double option, but it doesn't have one for integers. And what it does is tell you which one of the two boxes contain the smallest number. So what it's going to do is when, for example, in this example, we have the first box holding 44 and the second box holding 100, is going to compare both numbers and store the smallest one in the first box. In this case, all remains the same since the first one already had the smallest number, but if it was flipped, then the first one would be updated with the value of the second. Now we have to talk about a very different type of instruction. This is called the jump instruction. Now the jump instruction is quite different. It only takes one argument, and this argument is always an address. And this address has to point to another instruction. And what it does is when it executes, instead of continuing with the next instruction, it's going to go to the instruction pointed at by the address provided. So again, this address points to an instruction, and the jump instruction simply tells the CPU to move on all the way down to the instruction that is pointed at by the jump instruction. So it's going to skip, for example, in this case, the add instruction that was in between the jump instruction and the address pointed at by jump. Finally, we reach the last instruction I want to talk about, which is the compare instruction. Now, the compare instruction is going to compare the value within the two boxes. Now, it doesn't change the value inside either of the boxes, but we'll see how to actually get the result of the comparison. So in this example, we start with a move instruction. The move instruction puts the number 4 inside the register RCX, which means that after that instruction executes, RCX now holds the number 4. Next up, we have the compare instruction, which is going to compare RCX and 3. Now we know that 4 is bigger than 3. Now for that, just remember, now comparison compared 4 and 3, and we know that 4 is above or equal to 3. Next up, we have the JAE instruction. Now, what this stands for is jump if above or equal, which means that the jump instruction is going to ask whether or not the previous comparison was between a bigger number than another one. So if the previous comparison was because of a number that was above or equal to the other number, then the jump will occur. If not, it will just continue directly. So in this case, because 4 is above or equal 3, the jump will occur, and then we'll skip the add instruction just like before. However, if let's say instead we had moved the number 2 inside RCX, then the jump would not occur and we would not skip the add instruction. So that's it. That's comparisons, and comparisons are always attached to some type of jump. This is all we'll see for now, and let's move on to a practical example. Okay, so now let's head over to level 3 for a significantly more complex look at assembly code. So once we're in this level, we want to check the code that affects the height of the wall. So for this, go to level 3 wall height, right click on it, and click on find out what writes to this address. Once we have this window pop up, let's shoot the top button, and now this line will appear. And let's look at all the lines of code around this line. So let's click on show disassembler. And now you'll see that you might appear like this, but if you scroll up, you'll have all of these lines right above the line that we care about. And then we have a bunch of int3 commands, and right after we have a bunch of int3s as well. I want to point out that the int3 command is essentially just a placeholder and it doesn't do anything. So for our purposes, ignore them. All we care about is between this line and this line. Okay, so let's look at the first command, and we know that this is a move command between doubles, right? So the SD part means that it's for doubles. And so we have two parts. We have the first argument here that is xmm0. This is a register. And then we have an address that is static on the right over here with brackets. So let's look at, first of all, let's look at this address and what it is. So if you double click on the command, this will show up, and then we'll have the address right here. Now I want to show you that, in fact, this address is identical to the address of the wall height, right? So if we compare these two, so this number here and the address of the wall height are identical, and this makes sense. So what we know is that we're moving the value of the wall height into the xmm0 register. Now I also want to show you that here on the right we have a comment section. The comment section is a place where Cheat Engine gives you the value inside each static address. So it's saying inside the box at this address, we have the number 190, which makes sense because that's the height of the wall currently, right? So it's loading into XMM0 the height of the wall, which is 190 right now. Okay, so next up, I want to show what's inside XMM0. And for this, we're going to use the breakpoints like we did before. So I'll head over to debug and click on toggle breakpoint. Again, you can also go to view, click on show debug toolbar and click on toggle breakpoint right here. So select the first one and click on toggle breakpoint. Okay, now let's highlight in green. Let's shoot the blue button again. And we see here the registers. Now, I would like to see what's inside XMM0, but as you can see here, XMM0 does not show up. It's all the R registers. In order to see XMM0, we have to click on this little arrow, which will expand the menu. So if you click on it, it will show you the FPU menu. And what it is essentially, these registers are specialized for floating point and double point values. So in order to see what XMM0 holds currently, as we know that the height of the wall is a double and not a float, click on this little drop down, click on double, and this will change them. Okay, so we froze the game right before executing, right before increasing the wall height. So currently XMM0 holds 0, so it holds nothing. But as you'll see in just a sec, so let me change this a little bit. Here you go. Now, if we click on step over, we'll move on to the next instruction. So we'll see what happened to XMM0 once this command executed. So click on step over. And now we have in XMM0, we have the value 190, right? And that makes sense because we moved the value of the wall height into XMM0. Okay, good. Next up, we are going to do an add operation. Now, the add operation is between XMM0, again, so the register that holds 190, and this static address. Now, we don't have the static address in our list over here, so what we can do is double click on it. Now, copy paste this number, so Control C here, say OK, and then go into over here where it says add address manually, copy paste it here, change the type to double, and press OK. Okay, once we have it, you can see that it holds indeed 30 as the comments suggested. And we're currently adding 30 to the wall height, right? Because XMM0 holds the wall height. So what it's doing is essentially it's increasing the height of the wall inside the XMM0 register. So it won't appear yet in the game because we haven't changed the value inside the box. But currently what we have is inside XMM0, the height of the wall plus 30. Okay, so for now, let's just remember what XMM0 currently holds. So it's the height of the wall plus 30. Next up, we have another move operation, but this time into XMM1. And what it's moving here is 160. So we can do the same thing again just to keep track of this box. So copy paste this, add address manually, fill it in, press OK. And now we have it over here. Now XMM1 now holds 160 after this command executes. So we can again step over. And then once we step over, we should be able to look at the results here, and we can see XMM1 holds 160 and XMM0 holds 220, which makes sense because 220 is 190 plus 30. Okay, so now we have a compare operation. Now the compare operation is between XMM0 and XMM1. So XMM0 has 220 and XMM1 has 160, and we know that 220 is bigger than 160. So now we keep going since the compare operation doesn't do anything directly inside the registers. And now we go to the jump operation. Again, this one we saw it before. Jump AE means jump if above or equal. And we know that 220 is above 160, so the jump must occur. So once I click step over, you'll see that the next operation is this one. And the way that we can see this is that the jump operation is given an address, which ends in 19EF5227. And we can see here that indeed this line here matches the address provided to the jump instruction. So let's see what happens next. Let's go step over, and then there you go. It jumps down to this address. And now this one, we saw it as well. This one is a min operation. Now the min operation saves into the first box the minimum out of the two boxes that are provided. So XMM0 currently holds, as we saw, 220, and then this address here apparently holds 400. Let's do the same thing just so we can keep track of this box. Press OK, go to add address manually, give it in, press OK, and as you can see, it indeed holds 400. So the minimum between 220 and 400 is obviously 220. So XMM0 is now at 220 again. And then we move on to the last operation, which moves 220 into this address over here, which is identical to the address of the wall height. So what it's doing is finally updating the box of the wall height. Okay, so once we, if we click run, you'll see that indeed the height of the wall increased. And we can see here that the height of the wall is indeed 220. Okay, so now why not just do the add operation and then save it right here? So what it's doing really is that when we shoot up, oops, sorry, I forgot to disable the breakpoint. So disable the breakpoint and press run. So once we shoot enough, we reach the top of the wall, and then we can't increase it anymore. So the reason we can't increase it anymore is because this line here exists, which says take the minimum out of the two. So if the XMM0 now held, let's say, 430, then XMM0 would be updated to 400. So let's see this in action. So let's toggle the breakpoint and let's shoot a box. Now it freezes the game, and then we can see the XMM register as we go along over here. So okay, we load into XMM0 the value of the wall height, which is 400, so the maximum, and we step over, and indeed it has 400. Now we add 30 to 400. Now it has 430 over here, you can see. Then we keep going, we compare with 160. Now 430 is bigger than 160, so it jumps nonetheless. Now after it jumps, we do the minimum between 400 and 430, which is 400. So instead of having 430, this will change to 400. There you go, now it's 400. And then now it stores 400 into the wall height, and then it remains at 400, right? So what it's doing is essentially capping the wall height to a maximum of 400. It doesn't let it go anywhere above it. But we know that this happens thanks to this minimum operation. So what we can do instead is change the value inside this box so that instead of being 400, we can put it at, let's say, 800. And so it will limit the height to 800 instead of 400. Let's see this in action. So let me remove this breakpoint and let it run. And let's head over to the box that we saved over here that held 400. Let's put it at 800. Press OK. And now that we do that, the minimum operation will compare with 800 and let us just increase the value up until we reach a height of 800. Now we can keep going with this. We can, let's say, put 10,000 and keep going up. But now it's a little slow to click the up because we only increase by 30, right? So every time that that we run this add operation, we only add 30. But we could indeed change this to indeed add 1,000 instead. So let's do 1,000 here. Press OK. And then if we press up, it launches the wall way higher up. So there you go. That's all I wanted to point out. We can also change this value here to do something a little weird. So it was 30 before, so let's do minus 30. Now if you shoot down, you'll see that you go up, and if you shoot up, you'll go down. And this makes sense because the amount that we're adding is now negated, so we do the opposite operation. Okay, so that's all I wanted to show you, is that you can read through the code and do slightly more thoughtful things. So you can read through it, understand what it's doing, and then very cleverly modify values or add code injections in order to really get any sort of result that you want. You can get very creative with this. Now, another example that you can do is, we know that this value here holds the minimum that it can go to. So if we go here and change this to, let's say, 0, press OK, you can see that we can lower it all the way down to the floor now. So that's it. I just want to point out that you can look at assembly code, really understand what is going on, and put any effect that you want into the game. Okay, so let's look at how to build the following hack. So we're gonna go into the red zone, we take damage, and then if we head over to cheat engine, we can click on this cross, and then it gives us infinite health, as the name suggests, and we disable it, and it goes back to normal where we take damage, and we click on it again, we get health again. Okay, so this is called a script over here. That's how it's called, And you'll see that it's not like a value like the other ones. It doesn't have an address or anything. It's just a script that you can turn on and off with the little checkbox. Okay, so we're gonna see how this is made. So let's head back to the menu. I'm gonna remove it, pretend like I never did this, and I'll walk with you to figure out how this works. So the first thing we're gonna do is go back to the line of code that affects our health. So we know it's this one. Double click on it, which will open the disassembler as well. And what we can do is now we're gonna build the entry that goes in here that we can turn on and off. So to do this, we're gonna click on first. Make sure that you selected the right assembly language instruction. So once it's selected in blue like this, click on Tools and go all the way down to Auto Assemble. Once you do this, this window will show up, and in here is just like a text editor where you can write assembly code. But first we're going to click on Template, and now follow my instructions exactly as I go along. I'll explain what these do later, but first click on Cheat Table Framework Code, and in that order specifically. So click first on this one, and then click on Code Injection. Make sure you have the right one selected. It will say on what address you want to jump. This should match exactly the one that over here, the address here, where that matches with the address you want, the line of code that you want to replace. Press OK, and now this will all fill up, and we're gonna modify the code in here. So what this does is the first part says enable, and the second part says disable. This is created when we click on Cheat Table Framework Code. Okay. So the disable part is the part of code that once the checkbox is disabled, it will run this, and when it's enabled, it will run this. Okay. Now we're gonna ignore a lot of what's here. All I want you guys to know is down here is just resetting everything back to normal. So exactly the way it was before. So like restoring the code back to its original version. And then here we have the enable part. We're going to ignore all of this. We're going to ignore this as well. We're going to ignore all of this. We're just going to focus on these 4 lines right under original code. So this little 4 lines, I want you guys to notice that they're identical to these 4 lines here. Okay. So exactly the same 4 lines, copy pasted again. And the line of code that we want to change is this one, right? So if I remove it completely and I click on File and Assign to Current Cheat Table, it will show up here. Okay, you don't need to click on execute, so don't click on it at all. We can close this as well. We can double click on auto assemble script, and we can call it infinite health. Press OK, and now once we go in and we turn it on, as you saw, since we removed that line of code, now it does nothing, right? So currently the line of code does absolutely nothing, and when we disable it, it goes back to acting normally. Now let's see how to change it to increment instead. So let's right click on it and click on change script. Once we do, we'll be back here in this window. Again, remember this line of code is the one that we changed. And now we can change it to increment and then RCX again. Okay, so this one again is the one that does +1 instead of -1. Click on OK. Once you do, it will update over here. So now you can turn it on. And once it's on, you gain health. And when you disable it, you lose health. Okay, so that's the way to make scripts. So scripts are custom code that you wrote that you can turn on and off from here, which is significantly more useful than going to advanced options, which is here. Oops. Advanced options, then right clicking, then click on replace it with code that does nothing, or opening the disassembler and changing it manually. With this technique, you can directly have access to it as a little checkbox here, so turn on and off. Now, if you head over to advanced options and click back on the disassembler, click on tools and click on auto assemble, I want to point out again that it's really important to click on template, then cheat table framework, and then code injection. Don't do code injection and then cheat table framework. This won't work. And again, if you click on cheat table framework code, this shows up, which allows you to have a disable and enable section, which allows you to display it here. And once you want to save this, click on File and click on Assign to Current Cheat Table. This will display it over here. Okay, so if you click on File, Assign to Current Cheat Table, you save it here. If you don't, let's say you press Execute, you will lose access to it from here. So it's very important to click File and Assign to Current Cheat Table. Okay, that's it. That's how to make a script. As we go along, now we'll step up our game and actually start building a complex logic behind what we're doing. Okay, now before we keep going with more complex stuff, I'd like you guys to practice making your own script. So we can head over to level 4 and we can build a script that gives us infinite ammo. So I'll let you guys try it and then I'll explain how I would do it. Okay, so the way I would do it is I know I have the ammo here, so I would right click and click on find out what writes to this address. Say yes, click on the second option. I get this window. Now I want to know which instruction actually modifies the ammo, so I shoot around. This pops the instruction up. I click on show disassembler. Now I have it over here, and I click tools. I click on auto assemble. Then I click on template, then cheat table framework code. This gives us the enable and disable section. Then I click on table again, template again, and I click on code injection. I say okay to this. And now we have all the instructions here. And now I know that under original code, I have the instruction that I care about. So here I could, for example, put increment and press on file and click on assign to current cheat table. Now this shows it up right here. So I'm going to close everything. This. Now here, I'm just going to rename this to infinite ammo. And then I shoot, I still lose ammo, but as soon as I turn it on, I gain more ammo every time I shoot. Okay, so this is how you can make infinite ammo, and I just want to point out that it was extremely quick. It just took a couple seconds to get it running, and this was with me even explaining a little bit. So you can imagine how quickly you can build these scripts once you get started. Okay, so now let's recall what we did before, which was this little script called infinite health. And if we go over to level 5, what it does is, again, if we go in the red zone, we take damage, and when we turn it on, we gain health instead of losing health, right? So, now let's head over to level 6, and let's look at how this level works. So let's turn off the script and see how we could try to beat this game without hacking at all, or without cheat engine. So it says, for this challenge, you must reach the last platform and eliminate all training dummies. Similarly to the last challenge, the red surface will damage your health. Okay, so let's close it. And in fact, this game, you can technically just win it using the infinite health, but as we'll see, it'll be a little more difficult. So let's shoot the enemies, and you can see the health updates next to them. We'll jump to the next platform, then shoot. You can see the health goes down to 2, 1, and it disappears. Now let's try jumping across. We take a bit of damage, that's okay. We kill the next one, keep going, and then we jump. Okay, so we're down to 5 health, and now we have these 4 training dummies to destroy. So each one has a health of 5 in front of us, and the last one has a health of 8. So we can shoot them. Good stuff. Alright, almost done. Now we can try reaching the next platform. Oof, we made it with 1 point of health. Okay, we can kill the last one and then try to reach the last platform, but we can't because we don't have enough health. So now you might be thinking to yourself, okay, easily we can just turn on the infinite health and just walk around the red zone, and we can just reach the last platform easily. But we can't, because when the infinite health hack is turned on, not only do we have infinite health, but when we shoot the enemy, they also have infinite health. So technically, we could disable it, shoot the training dummies a bunch, move on to the next one, kill him. Now that we're starting to get low on health, we turn it back on, we heal a little bit, and we keep going like this up until we reach the last platform. So indeed, the infinite health hack is more than enough. However, it's slightly inconvenient to do, and I would like to show you a way to just turn on infinite health and it only applies to you. Okay, so now let's try to understand what was actually happening in the last clip in order to be able to actually figure out a solution for it. So let's go into advanced options and head over to the instructions that we care about, the DEC in brackets RCX. Now, again, for probably the millionth time, and you guys are probably tired of me saying it, but if you want to obtain it and you don't have it in the code list, just right click on find out what writes to this address, head over to level 3, so over to level 5, sorry, and then take some damage, and then the instruction will show up. So once you have it, right click on it, open this assembler, and now we have the instruction. So now what we want to do is understand how come modifying or making a code injection at this location messed up with not only our health, but also the health of the enemy. So let's have a look. So first, let's go with debug and toggle breakpoints. Once you have it on, let's look at what happens when we take damage in level 5. As expected, we take some damage, and then RCX holds the address of our health, right? So 243B blah blah blah, it's the one that is right here. This one is identical to this one, right? Let me show it a little better. So okay, so RCX holds the address of our health, and so it decreases our health every time that we touch the red zone. Okay, cool. Now I'm gonna remove the breakpoint and click run so the game keeps going, and I gain control again. So now let's go to level 6 and do the same thing. If I toggle the breakpoints and I take some damage, now again RCX holds a new address. This time is a little different. It's not the same one because it's not this is the level health, the level 6 health instead, but nonetheless this is definitely the address of the health of the player in this level. So what it's doing is decrementing this health as well. So again, let's toggle breakpoint to remove it and press run so that the game goes back to normal. Let's go back to level 6 and let's toggle breakpoint for the last time now, and if I shoot one of the enemies, it again freezes the game, meaning that again we reach the exact same instruction, and again RCX now points somewhere else, which we can assume is the actual health of the enemy. So what's going on is essentially that the game reuses the exact same line of code to reduce the health of our player in both level 5 and 6, and also reduce the health of the enemies. So it uses the exact same line. The only difference is that it loads into RCX a different address. So it changes the value inside RCX in order to point to a different health, but behave exactly the same. So reduce the health every time. So when we activate the infinite health thing and we basically override this line and do a code injection in order to increment health instead, what happens is that instead we apply the change to everything that uses this line, and it so happens that the game reuses the same line for enemies and for the player. You'll notice that this will happen very often when you try doing this on your own, and the reason why is because game developers are quite clever and they want to reuse as much code as they can. So they can write less, and it has other advantages that we don't need to get into, but it's very common for game developers to reuse the same code for multiple different purposes. So when this happens, we want to be able to, within our code injection, determine whether or not this use case is for the player or if it's for the enemies or for whatever two groups that you may find yourself in. What we can do now is to have a really good look at what's actually going on and how RCX changes value depending on where the decrement operation is being used. What we can do is right click and click on find out what addresses this instruction accesses. So this won't show up if you have the breakpoint enabled. So make sure to disable it. And once you disable it, you can right click and click on this option here. Once you do, this window will show up. And I just want to point out a few neat tricks about it. So if I, let me just have it right next to the game. So now if I shoot an enemy, you can see that an address shows up. This is the address held inside RCX. So again, this window gives you all the addresses accessed by the instruction that you chose. And since this instruction only accesses the one inside RCX, this gives us the address inside RCX when it was called. If I shoot another dummy, it will give me another address, which is the box holding the health of this dummy. And if I take damage, it gives me another one, and so on. And if I shoot the other dummy over there, it will also give me the address of that one, because essentially what it's doing is giving me every address that this instruction accessed. And because it ran this instruction for my health and the health of all three of these dummies, then RCX had to change to all the different addresses, and therefore they all show up here. So now that we know this, I'll cover the actual solution in order to determine whether the address is the one of an enemy or if the address is the one of the player. Okay, now let's see how we can determine whether or not the execution of this instruction is for a player's health or an enemy's health. And to do this, we're gonna again right click and click on find out what addresses this instruction accesses. So if you have it already open with values, just close it and open it again. If you try opening it again directly, you won't have the value. So now that we have it, I have it here. Let me move this around and let's go back to level 6. So in level 6, if I take damage, obviously my health shows up. So this is the address of my health. And again, just to point out, this says I have the value of 6, which matches, and a count of 4. That means that 4 times the instruction DEC RCX here was executed with RCX having my address, right? The address of my health. Now, if I shoot a dummy, it shows up as the value of 2, which makes sense because its health is 2. I shot it only once, so the count is only 1, and this is the address of the dummy. Next up, let me shoot another one, and then a last one. Okay, so now they all showed up. Let me, in fact, even modify a few of them. So there you go. So now we have different values for each one of the dummies. The one with 0 is the one that disappeared. Regardless, what we have now is 4 addresses, and what we can do is group them. So what we're going to do is try to group them in order to determine some sort of way to determine whether or not it's part of the group of enemies or the group of the player. So to do this, let's select the last three, which are all the dummies. To do this, you can hold Control and click, or you can click on the first one and hold Shift and click on the last one. This selects again all the consecutive ones. Now you can right click and click on Find Commonalities between between addresses, and mark these as a group 2. Okay, so they all turn red. These are all the enemies, and we know that this is our health. So we want to make a difference between these 3 and this one. So we're going to mark this one as a different group. So go ahead and mark it as group 1. Okay, so now we have group 1 is the address that we want to give infinite health to, and then we have the group 2, which is the one where we want to decrease health from. So now we have the 2 groups, and again what we can do is simply right click on any of these, it doesn't matter. Again on Find Commonalities between addresses, and this time instead of marking, click on Scan for Commonalities. When you do this, this little window will show up, which will tell you basically the values of the registers, all of the registers, when this instruction executed. Okay, and it's gonna say, okay, for all the ones in group 2, for example here, it says for all the ones in group 2, R8 had value 1, which means that RCX had the address of the health, which was the one of the enemies or ours, but it says for the ones that had the enemies or the group 2 that we selected, every time R8 had value 1, and for the ones in group 1, it had some other value that was not 1. Okay, so what it's telling us is that we can use the value of R8 to distinguish between this group here or this group over here. It's saying that every time that we're in this group, R8 had value 1. Okay, so we can use this information in our code injection with a compare statement in order to determine whether or not R8 has value 1, and therefore determine whether or not this is a player or if it's an enemy. And based on that comparison, we can give different behavior, as we'll see in just a second. So that's what I want to point out. So we can do this grouping and scanning for commonalities in order to determine the values of the registers at the execution of this command, in order to determine some form of way to decide whether or not the operation was running for an enemy or for the player. Okay, so now we know that R8 has common value 1 for group 2. So we know that if R8 has 1, it's an enemy. Okay, so with that information, we'll be able to create a code injection. Okay. Okay, so now that we know that R8 is a register that holds the value 1 whenever we're shooting an enemy and doesn't hold the value 1 when it's for the player, we can actually make the difference within our script here. We can actually modify it in order to behave as wanted. So now let's open it. So let's right click on it and click on Change Script. And I want to cover a lot of information in this video, so please take it slowly. And if you ever feel like you don't understand something I mentioned, pause the video and focus on that part only. Don't try to push through the entire video at once, because it might get like way too much information all at once, and it might be hard to understand. So let's first focus on these two int3 instructions. Now, I mentioned before, int3 is a completely useless instruction. It's just a placeholder, and it doesn't do anything. So we can in fact just delete them. And just to prove that they do nothing, we can press OK and turn on the script. And again, if I shoot the enemy, they gain health. If I touch the red zone, I gain health. So again, it just keeps functioning exactly the same as before. Now let's go back to change script. Next up, I want to talk about this ret instruction that we haven't seen before. So what ret does is, actually it stands for return. So what it does is return back to where it was before the code injection. You don't have to worry about what ret does, you just have to know that it has to be the last instruction that executes at the end of the code injection. Okay, so currently it's fine because it's right under increment. So as long as it's the last instruction that executes after what you want to achieve, then you're set and you're good to go. So what we're going to do is actually remove it and put it right under exit here. So what it's going to do is run increment, go down, hit this, that we'll talk about what this is later, and hit the ret instruction and terminate the script. So up until now, it just executes like this. Now, what is this exit thing? Exit, original code, new mem, and a couple other, I think, return here as well. All of these are labels. So you can see here, label, return here, label, original code, label, exit. All of these are labels, and the reason they exist is because for jump instruction like this one here, it says jump to return here. And I told you that jumps you typically use addresses. However, as you can see here in this text editor of the auto assemble option, it doesn't have any addresses here on the left. So we need some way of referring to a piece of code. So instead, we create these labels. So these labels will be transformed into addresses later on. But for now, what they do is really just provide us with names so that we can tell where to jump to. So let's now, since we want to have two different behaviors, we'll make two different labels. We'll have label player and label enemy. This will allow us to split the code into two different parts and jump to two different parts depending on what kind of behavior we want. So we're going to go right under increment, and we're going to place the player first, and then we're going to place the enemy. Okay, so now what we want to do is we're going to remove this increment right here, and we're going to compare R8 with 1. So we know that R8 is equal to 1 whenever we are shooting an enemy, right? So if R8 is equal to 1, we want to execute the code for the enemy. Currently it's empty, but we'll get to the code of the enemy in just a second. So now we know that every compare instruction needs to be paired with some jump instruction. We're going to pair it with a JE instruction. JE stands for jump if equal. So it's very similar to the one that we saw before of the jump if above or equal. This one is just jump if it's exactly equal. So it will jump if R8 equals 1. And since we know that R8 is equal to 1 when it's an enemy, we're going to jump to enemy. Great. So now, if it's an enemy, we're going to go under enemy right here, and we're going to do decrement RCX. Okay, so if it is an enemy, so if R8 is equal to 1, it is an enemy. So jump to the enemy label, and when it jumps to the enemy label, it's going to execute the following command. So until now, it makes sense, right? So if it is an enemy, it goes here, it decrements the health. So that's good. The enemy is all set up. Next up, if it is a player, we want to increment RCX. So what it's going to do is compare R8 and 1. If it's equal, it's going to jump to the enemy and decrement the health. But if it's not an enemy, meaning if R8 is not equal to 1, it won't jump, and it will just keep going down, and it will hit this instruction, which will increment our health. Okay, so let's press OK and see what happens now. So if I turn it off and turn it back on again, this will update the script in memory. So if I shoot the enemy, you can see that it decreases their health. Now, if I do touch the red zone, you'll see that my health is infinite, essentially, but it doesn't increase like we expected. So why is this? Let's disable the script, right-click and click Change Script and see what happens. So if it's not an enemy, the jump doesn't happen. So it's our case when we touch the red zone. So we're the player, it increments our health, but then it keeps going down and it hits the decrement. So what it's doing is +1, -1, and for that reason our health is frozen at 14 at this moment. So what's going on is it's doing, oops, I disabled the script so it doesn't work, but if I turn it on, you'll see that again our health is completely frozen, and what it's really doing is increasing by 1, subtracting 1, and then continue going. So let's disable the script again, and now let's fix this. So we know that if we are the player, we don't want to execute the part of the enemy. So what we're going to do is right under increment, we're going to make a jump that doesn't include a compare. So this jump is unconditional. It jumps no matter what. And we're going to make it jump to exit. The reason we're going to make it jump to exit is because we want to skip over the enemy part. So what it's going to do is compare R8 with 1. Again, I'm going to explain everything from the beginning just in case. So it's going to compare R8 with 1, which we know that R8 is equal to 1 if it is an enemy. If it is an enemy, so R8 equals 1, we're going to do a jump if equal to the enemy label. Then it's going to skip all this, and it's going to hit the enemy section, decrement RCX, and then go down to exit and hit the red instruction, which will go back and terminate the script. So next up, if it's not equal to 1, it doesn't jump. So it goes down to the player section, it increments RCX, so it increases our health. Then it jumps to exit, which skips over the decrement operation, hits the exit, returns, and everything is good. So let's see if this actually works. Let's turn it on and let's touch the red zone. And indeed, it does work. And it does damage the enemies. Great. So now we have the script happening, working correctly. It gives us infinite health, but it doesn't give infinite health to the enemies. So now I want to point out another thing. So we can make the script better because when we shoot the enemies, you can see that we have to shoot them a lot of times. So 5 times for these and 8 times for the one over there. And it's very time consuming to do and annoying. And I would rather just shoot them once and be done with each dummy with only one shot. So what we're going to do, disable the script again, right click and click change script. And once you do, instead of decrementing their health, what we're going to do is we're going to do a sub, which stands for subtract, which is the opposite of add. So it's doing minus instead. And we're going to do minus 0A. Now, 0A is 10 in hexadecimal, right? So if I open the calculator and I write here in hex, I write A, you can see that we have 10. So what we're doing is subtracting 10 from RCX. And once we do, what we do is remove 10 from their health, but they all have less than 10 health, so it should kill them all in one shot. Now this would work, so if we press OK and turn it on and shoot, again it works. Now, just as of just out of completeness and making this as perfect as we can, let's go back to change script. And remember that I talked about this whole D-word PTR, right? Now, I told you that D-word is for 32 bits. And if you don't put it, it's going to assume it's 64-bit. Don't worry too much what the difference is, but what I want to point out is that we know that the health in this game is stored in a 4-byte box, right? So the type of the health is 4 bytes. And 4 bytes, each byte is 8 bits, so 4 bytes is the same as 32 bits. So by adding this, we make sure that we don't by mistake modify an additional 4 bytes that we wouldn't want to modify, right? Because these operations will execute on typically 64-bit boxes. And so if we don't specify this, we might be modifying a box that is nearby by mistake. So what it's doing is saying, please, computer, only modify 32 bits. Don't modify more than 32 bits. For our purposes, whether or not you put this, it should still work regardless. But it's always good if you have a 4-byte box to use the D-word PTR declaration. Okay, so put it, press OK, and this will keep working just as before. Okay, so again, we only need 1 shot per dummy. We have infinite health. We heal when we touch the red zone. And we can, no matter how big the dummies are or how many health they have, we can just one-shot all of them. And we reach the final platform as we wanted. Okay, so this is how the infinite health script can be updated. And this is how you determine whether or not the instruction is being used for the player or for the enemy. And this will happen very often in video games where game developers will use the same line of instruction for 2 different scenarios. And you can use this find commonalities trick that I just showed in order to see if one of the registers has a value that is specific to one of the 2 groups. And with that, you can actually build a script just like we did with this compare instruction over here. So, and then you can use the labels that I showed in order to jump to different parts of the script as needed to skip parts depending on what the comparison resulted at the beginning. Okay, so now I've glossed over something regarding commonalities called structure comparisons, and I want to explain this to you just so that you have access to it for your future journey in hacking. However, we don't need it for this video game, but I just want to show it to you nonetheless. So I've already gone ahead and made the two groups. So I have the groups over here for the enemy in red and in blue for the player. If you right click and click on find commonalities between addresses, click on scan for commonalities. Now this menu shows up that we've seen before, and we paid attention only to this line that specifies that the register R8 holds the value of 1 whenever it's in group 2, meaning that if we enter this code over here and it happened to be when shooting an enemy, we can rely on the value of R8 being 1 in order to determine that it is indeed an enemy, and if it's not 1, then it's the player. So we've seen this already. There's also here other values. So this one here, it says that R14 has value 0, R9 has value 0, and RDX has value 0. The reason I picked the one that has value 1 is because oftentimes the value of 0 is just a coincidence because the value of 0 is just so common. However, this is not necessarily the case. Sometimes the value of 0 is reliable and you should try using it. So you can go ahead and try changing over here to R9 like this. R9 and putting 0 over here and seeing if that works. But for our purposes, I am more interested in the ones that say double click to launch structure compare. We're gonna do this. So double click on the one of RCX, for example, and this menu will show up. And for our purposes, we're gonna set this to max level of 1 and click on only find matching groups. Press scan, and then I'll explain what we're actually doing here. So press scan, save this somewhere, say yes. And once we do, this list will show up. Now what we're doing is asking Cheat Engine to provide us with boxes in RAM that we can use as opposed to registers directly. So what we're doing is saying, go to the address of RCX. So in this case, RCX was holding this value for our health, or these values for the health of the enemies. And it's saying, go to those locations in RAM and give me offsets over here that you can see, offsets from these addresses that hold some sort of value that I can use in order to build the script. So instead of using R8 directly, we're going to do RCX plus something, which this will be the offset. So for now, I'm just going to write offset and comma and then some value here. So the offset here, we could use, for example, D8 over here. Although D8 seems to be unstable, let's find one that is a little bit more stable. This one here seems to be stable. It doesn't seem to be moving, so 3EC. So let's do 3EC. And it says here that group 2, so you can see G2, 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 or just the ones that are in red, at this 3EC has value of 0. And it seems to be quite reliable, right? So we are going to do compare with 0. Okay, so we're doing at the... Okay, so we went to the register RCX, we went to the address of RCX for all of them, and at this specific offset, 3EC, we can see that all the group 2s have a value of 0, and the other group, so group 1, has some other value that is not 0. So we can use this value here to compare whether or not it's the enemy or the player, group 1 or group 2. Now, again, I just want to point out that this might be unreliable, and it likely is. This is the first time I actually try with this specific offset. We'll see if it works or not, and if it doesn't, we'll see an interesting case where we notice that it doesn't work and how to deal with it. So, perfect. So, again, just clarifying, we have RCX. RCX holds the address of our health, and then here it provides us with offsets with some values that we can use. In fact, here you can see that at offset 0, meaning without any offset, we end up with the value of 6, 2, and 2, and 2, which makes sense because all the enemies have a health of 2, and we have a health of 6. So this makes sense, but we can't use this because as soon as the health changes, then the values are not reliable anymore. So let's try to use this 3EC with values of 0 for all of them. Press OK, close this, go back and let's shoot enemies. Sorry, I forgot to turn on the hack. So don't forget to turn it on, otherwise it definitely won't work. So let's shoot the enemies over there. This one worked immediately. Great. And let's see what happens when we touch the red zone. Okay, it seems to be working. Everything seems to be working perfectly. Let's go and try to do this on the other dummies. So let's shoot the dummies over here and see if it works. That one worked. That one worked. That one worked. And let's try the last one. That one worked as well. Okay, so it seems like it's working. But let's not be so sure just yet. Let's actually leave the level and come back and see if it works. So let's shoot the enemy over here. And as you can see, it stopped working. Okay, so if we go back into the script, this means that RCX plus 3EC with RCX being the health of this dummy here, it does not work, right? Meaning that this is not equal to 0 anymore. Meaning that what we found was unreliable. Now, this is perfectly normal, and I just wanted to point out that this technique exists. It takes a lot more time to find reliable results this way, but sometimes you don't have another choice. So this is structured comparison, at least the simple basics of it. I just wanted to point out that this exists and how to actually access the values within code, so that in case that you find yourself in a position where you can't find reliable results easily, like using this exact thing where it says like some specific register has a specific value, you can launch the structured compare and see what you can find. Okay? So that's it. I just wanted to point this out. From now on, we'll keep using R8 because it's by far the most reliable results, the most reliable technique. So let's do R8 and 1. And again, just to clarify here, we don't have to use the brackets or give an offset because simply the R8 register, we want to use its value directly and not use anything inside of the address of R8, because R8 simply holds the value of 1, which is great for us. Okay, so now what if we wanted to change the value right here? But we don't want to open the script every time that we do this. We would like to change it right from this menu here. So to do this, let's first learn about allocating new memory. So right under the labels, you can write alloc and then the name of what you want to call it. So let's say enemy damage. Then how many bytes you want to use for this number. So as we know, most of the health is 4 bytes, so we can simply use 4. And then we have to tell CreationEngine where in memory to allocate this. And basically you're going to give it an address and it's going to start looking from there for some empty room in order to allocate it. So we're going to use exactly the same one over here. Now, what CreationEngine is doing over here is exactly the same thing. However, it's allocating memory where we can actually run code. We're going to allocate a little bit more memory to guarantee that we have some room for the number that we want to store. Next up, let's say enemy damage and colon. So it's acting the same as a label. Next up, we have to declare what the value is. So to do this, we have to do dd and then let's press 1. So dd stands for declare double word. So if you were to write W, it would be for 16 bits or 2 bytes. So you know a word is 2 bytes, as we said before, and a double word is 4 bytes. So double word is what we need. So for now, we're going to make 1 damage to the enemies. And then we're going to do something else called register symbol. And then again, enemy damage. What this is going to allow us to do is, so the first thing is to declare 4 bytes of memory to allocate a number. Next up, we declare a number here as dd1 under the enemy damage label, and then we register the symbol enemy damage. And this register symbol is meant so that we can access it from over here, as you'll see very soon. Next up, scroll all the way down, and we're going to write these 2 things. So deallocate enemy damage, which I wrote before, but it's in order to remove this memory once we disable the script. And then we are also going to unregister the symbol enemy damage. Okay, so once you register it, you have to unregister, and if you allocate, you have to deallocate as well. Okay, so now that we have this, let's go back in here, and then let's click on add address manually. What we can do is write address enemy damage and press OK. When we do this, what we're assigning is the value of enemy damage, which will display once we turn on the script. So let's turn it on. As you can see, it changes to some address and it has the value 1. Now that we have the value, we have to actually use it in the script. So to do this, let's move into R8 the value of enemy damage. So we know that enemy damage is an address, so let's provide it within brackets. So what it's doing here is moving inside of R8 the value inside enemy damage, which we know is 1 because we declare it to be 1. Next up, let's subtract R8 from the health. So we can just R8, since R8 is now holding the amount of damage we want to do to each enemy. And then we restore the value of R8 back to what it was. Since we know that it's an enemy, R8 has a value 1, so let's move back 1 into R8. And this is so that we don't cause any problems later on in the game. So as far as the rest of the game goes, R8 was always 1, since we changed it here for our purposes and set it back to what it was before. Now, if you try putting this like this, meaning that directly use enemy damage instead of passing through R8, this won't work because the sub instruction does not allow you to put an address directly on the right side. So for this reason, we have to use R8, but otherwise it would make sense to directly place it like this. This is just syntax. assembly code doesn't allow us to do this. So for now, let's use the register. Now that we have it, we can press OK and see how this works. So if we go and shoot the enemies, they lose health, and we gain health when we touch the red zone. Now if we change this to, let's say, 10 and press OK, and we shoot them, they all die immediately because we're applying 10 damage every time. So let's go see the other dummies. Okay, so now let's change the value here to, let's say, 3. Oops. Here's the value to 3. Once we do and we shoot this one, you'll see that it drops from 3. So here we can decide how much damage we want to make to enemies. So we can rename this to enemy damage. And then on top of this, we can drag this into the infinite health script so that it orders them right below. And on top of this, if you right click and click on group config, you can click on hide children when deactivated. You have to make sure that this is turned on in order for it to disappear every time you deselect it. So once it's selected, it shows up, and then you can change it to whatever value you want. You can put it to 500 if we want. And yeah, that's it. Now we get one-hit kills, and we can change it as much as we want. You can do exactly the same for our own health. So you could change the amount of damage that we gain when touching the red zone by creating another label, allocating some memory, and registering the symbol. And then when you touch the red zone, you will gain the exact amount of health that you want. So that's it. I just wanted to point out that you can register symbols to edit your scripts so that you don't have to always open the scripts. You can just change the values over here. And this allows you to structure your hacks a lot better so that you can keep track of what everything does. You can order them one underneath the other. That's it. That was just registering symbols. I just wanted to point out that you can allocate memory in order to set the values that you want. Okay, so now let's talk a little bit about what this ending over here is. So what this is doing is under the disable section, basically it rewrites the code that was there before the code injection. So let's have a look at what a code injection actually looks like. So if we look over here and we turn on the code injection, you can see that it turns into a jump instruction. If you right click and click on follow, it's going to jump to the instruction that you care about. And over here, you can see that it actually runs the code that we wrote. So you can see here first the compare instruction, R8 with 1, then the jump instruction, jump if equal. This is now what enemy stands for, increment RCX, jump to exit, and so on. It keeps going. And so this is the code that actually runs as part of the code injection, right? So if we were to disable it and it all disappears again, we can right click and on the DEC RCX, open the disassembler at this location, you can see that everything is back to normal, right? So if I turn it on, it turns into a jump instruction. If I turn it off, it goes back. So the way this works is that over here at the bottom, we have first the address where we want to make the code injection, right? So you can see this address over here matches this address over here. On top of this, there's this db command, which is declare bytes. Very similar how to declare double word that we used over here. It declares just bytes. Now, again, remember a byte is 8 bits and each hexadecimal number is 4 bits, right? So 2 of them make 1 byte. So here we have a total of 5 bytes. And you can see that these bytes match exactly the bytes that represent the instruction. So you can see here DEC RCX can be written in bytes as FF09. So you can see here FF09. Then C3 becomes C3 over here, which is the ret instruction. Then CC, then CC again for the int3 instructions. So this is used in order to replace the code that was there before when we disabled the code injection. Now, what we can do with this is handle essentially what happens when there is a game update. So in a game update, the code here will change, right? So there will be code that will be added before and code that was added after. And so this address over here for DEC RCX might be different in the next game update. But we don't want to rewrite the entire code instruction every time there is a game update. We would like it to be a little bit resilient to game updates. So what we can do is go to the top over here, and we're going to do something called an AOB scan. So let's go here, AOB scan. So what an AOB scan is, stands for an array of bytes scan. So AOB is just AOB, which stands for array of bytes, and then scan. And for this, we're going to provide first a name. So we're going to call this infinite health, because this is what the script does. And then we're going to add in the bytes to scan for. So the bytes to scan for are these. And what it's going to do is provide the infinite health label with the address of wherever these bytes appear in the code. So what it's going to do is go through the entire RAM associated with the game, is going to find the first set of bytes that match these, and the first one is going to be given to infinite health. So if you have a good enough set of bytes over here that is unique enough, infinite health will be replaced with the exact address of the start of this array of bytes, essentially making it so that no matter where this code moves after an update, we can always find it back. So now instead of referring to the exact position like this, so you can see that this code here again is exactly this address, we can simply replace this with infinite health. So over here as well, we go down, it's here as well, and here over here as well. Okay, great. Now press OK. Now you may expect that looking for array of bytes like this through the entire RAM is going to be very slow. And indeed, you'll be right. So if you go into level 6 and now turn on infinite health, you'll see that it will take a very, very long time before it actually turns on. Okay, and finally it turned on. So for me, it took roughly a minute to turn on. And now I'll show you a way to speed this up a little bit. Now, in order to speed this up, we can change the IOB scan command for an IOB scan module command. Now what this is going to do is look specifically for the module called beginner course win64 shipping.exe. So let's copy paste this in. So we first have to provide it right here. Perfect. You can type this one by one, but I just copy pasted it. And so now we have essentially telling Cheat Engine to only look for this array of bytes within anything related to specifically this, and not through a bunch of other modules that the game may be running. This will speed this up drastically. So let's press OK. Let's lower this, and then if we press infinite health, you can see that it turns on much faster. So this is great, great news for us. Now, if we go back into the script, I want to point out what would happen in case that this doesn't work. So let's say there is an update and that adds these exact bytes into the RAM, and now your script tries to inject itself into the wrong place in RAM. So let's say there's an update and some other place in RAM there's a DEC-RCX command, and then it messes up with your injection. So what to do in that case? So let's copy this, and then let's go into Cheat Engine, and now let's search for, instead of value type of 4 bytes or doubles that we did before, we can search for an array of bytes. When we do this, we can search for it directly and press on first scan. And as you'll see, nothing will show up. Now, the reason why nothing shows up is because here in the memory scan options, we chose a writable option. Writable is wherever the memory is allowed to be modified. Don't worry too much about this, but essentially this means that some parts of memory are not writable and some other parts of memory are writable, meaning that some places of memory you can actually modify the values and some other places of memory you cannot. But for now, let's just disable writable because we want to search for this array of bytes into the unwritable section of RAM. So let's do a first scan. And once we do, you'll see that there's multiple here that show up. Lucky for us, the first one is the one that we care about, but there's 2 more that we don't like, right? But we've done already an AOB scan module for this specific module, and as you can see here, we have other modules that are running. So we were lucky that within the module that we care about, this actual pattern is unique. Now, if this wasn't the case and it wasn't unique, what you could do is head back over in the memory viewer, and what you can do is add onto the end here more of these bytes that attach to the memory. So you could go all the way down and write down these array of bytes over here, and this will make it longer and more rare for it to be overlapping with some other array of bytes somewhere. So by adding more bytes, you can basically make sure that it's more unique, and therefore guarantee yourself that your code injection will always be allocated the right place. And for as long as that specific piece of code does not change during updates, Cheat Engine will be able to spot it every time, and then your code injection will survive even though the game has had an update. So this is how to make it so that your code injections are more stable across updates, is essentially the AOB scan feature. And if it doesn't work, which may happen, you can go and check which ones there are that match, and then try to make yourself make this one a little bit different, but by adding more bytes to it. So you can keep going, adding all of these. So for now, you could like simply add more like this, and so on up until you reach a point where this is the only one that exists. So that's it. That's all I wanted to point out. And this concludes the last topic that we'll be covering in this course, at least the last theoretical topic that we'll be covering. Okay, so we've reached the last chapter of the course, and I would like to leave you guys with some tips and tricks on how to move forward and keep learning stuff on your own after you're done with the course. However, before that, I want to cover something that is very important. I want to warn you that the stuff you learned in this course can be used for nefarious purposes, and a lot of companies do not allow this at all. So, if you go and practice this on other games, which I recommend that you do, make sure that those games do not have anything in their terms of conditions against stuff like reverse engineering. If their terms of condition disallow this kind of behavior, do not hack their games, because you would be breaching terms of condition, and therefore you are liable legally even. So please do not do this. You may get banned as well, so you might lose the money that you put in buying the game in the first place. So please be careful, okay? Just do this on games that allow this kind of behavior. On top of this, it goes without saying that you shouldn't do this on multiplayer games for two reasons. First, it wouldn't be ethical to ruin the experience for other players, and on top, it is very likely that the company has made it against their terms of condition to hack their game if it's multiplayer, mostly because you would be modifying stuff within their servers. So please do not mess around with any of this if the companies do not allow you to do this to their games, and apply these skills ethically. Do not ruin the experience for anyone else. Okay, just have fun doing it on your own on single player games that allow this type of behavior. Do not break any terms of conditions, do not break any laws, and please do not also ruin the experience for other players. Okay, so be ethical, be moral, and be legal when you do any of this. Okay, so just clarifying that I am not responsible for any decision that you make and any consequence that you have to face for what you're doing. So now I would like to leave you off with a little bit of guidance as to what you should be learning after the course is over. So other than practicing on games that allow it, you should probably learn to code. So the language I recommend that you learn is C++, and the reason is that C++ allows for direct manipulations of pointers, so it's much easier to build hacks using C++. On top of this, you should probably learn about GitHub. So GitHub is a website that people post a lot of code in, and using this code, people can then learn how to write hacks in C++ by looking at other people's code. So first learn C++ and then understand how to use GitHub in order to navigate around a bunch of code, and once you're able to read it, with your new knowledge of hacking that you learned in this course and a little bit of knowledge of C++, you should be able to figure out how standalone hacks work. So I recommend C++ and GitHub. You'll also be able to understand something else called the Windows API. So the Windows API is the main way to build external hacks. So the Windows API is the way that Windows allows programs like Cheat Engine to inspect the memory of other programs. And so by using the Windows API in combination with C++, you're able to build standalone hacks that are able to modify the memory of other games. And so that's it. That's what I recommend truly that you do after the course is over, other than obviously practicing, as I said. But once you're done practicing and you feel like you've learned enough, the real next step would really be to learn to code in C++. Unfortunately, I can't make this course about learning to code in C++. That would be a completely other course. But you should really learn to code and the Windows API and GitHub, which are by far the biggest resources for any experienced game hacker out there. Once you've learned enough experience, you should probably consider something else, something called bounty hunting or bug bounty hunting. So bounty hunting is the practice where companies will pay hackers to hack their games, and in exchange, the hackers will provide them with information as to how they managed to hack their games. And with this, the companies can then improve their anti-cheats, for example. In fact, bug bounty hunting is not only for games, it's also for companies that run, for example, websites or services. A lot of them have bug bounty programs, and you can actually earn quite a bit of money by being an ethical hacker and actually applying your skills for the good of others. So you don't need to be a hacker and be a bad person. You can actually be a hacker and contribute to society in a certain way. So I strongly recommend that you look into that once you learn enough experience. And so that's it. I really hope you enjoyed the course. Please don't forget to leave comments if you see anything that I should improve, and I will try to update the course as often as I can and take into account any comments that you guys make. So go ahead and please have fun with this new knowledge.
Thank you for watching. Subscribe now and press the bell icon. Never miss any update.